Hmm, that's happening. Huh, somebody's online. Hello, whoever you are, welcome. I'm not sure what we're gonna do today. But you're very welcome. Nice of you to join. Let's see. What do we have here? Right. I think what I was gonna try to do maybe is try out a little bit Advent of Code. I've been quite a bit behind on it, so maybe we can catch up a little bit. Let's see. These caves seem to be lava tubes, so I don't know how much experience you have with what's it called? With Advent of Code. But what we're gonna try to do is figure out where I left it. Let's see here. Right. Right, so right now we have one extra branch that I've... Oh, okay, I remember what I did. I think I merged everything into the main branch because I'm not sure if I wasn't sure if I was going to continue doing this. Okay, maybe we can just try to figure out one of these puzzles. These caves seem to be lava tubes. So I'm not sure how much familiar you are with the Advent of Code so far. But the issue seems to be that we lost some keys. Yeah, Advent of Code is just like this puzzle thing that goes up 25 days before Christmas every year, and it's like a coding challenge, a puzzle challenge. And every day there's a puzzle coming up, and in 11 hours there will be a new one unlocked, all the way until Christmas. And how it started now is that we have a submarine that we are. Yeah, we lost our keys to something that I don't remember that we were told in the first day. Yeah, trip the next. Oh, the sleigh keys, right? So we don't have the keys to drive the sleigh to deliver the presents. So that's a little bit of a bummer. They fell into the sea. So we took our submarine and we're trying to figure out where the keys went. And there has been a bunch of puzzles so far that we had to solve, and there is a bunch more. But I think I remember trying to solve this. I solved the first version of yeah. I didn't solve the second puzzle, but it wasn't so exciting to continue solving this now. So I remember there was one that was pretty fun, and I think it was some some sort of cellular automata task. Oh wow, what is this? That also looks pretty cool. Let's see which one it was. Um, Octopus is neatly. I think that's the one. You know, a cavern, a large cavern full of rare bioluminescent Dumbo octopuses. They seem to not like Christmas lights on submarines, so you turn them off for now. Right, yeah. Yeah, I remember that was kind of cool. So I think it was this. Yes, okay. So it has these three rules. Yes. So the octopuses they their energy levels change based on their neighborhood. So that is something similar to cellular automata, if you're familiar with. Opa. Actually, not even that. A game of life is maybe like the one popular one, which is based on some specific, yeah, there you go, specific version of cellular automata. Right, so you have a grid, and basically in each iteration, the entire grid is evaluated based on some conditions that you've set. And in this case here, let's see, I'm not sure which conditions we are playing with. If they, oh, there's a bunch of things here. Explanation maybe says what they, oh yeah, here we are. So here's the rules that each cell, like its piece of the grid, has been evaluated on, is like its block. So basically, if we find a cell that that has no neighbors, one or no, okay, that has only one or no neighbors at all, it dies as if it was very sad that it's by solitude. Yeah, it's very sad that it's alone. So in this case, this only has one neighbor, and this so this cell has to die in the next round. And it's the same for this cell up here. It only has this neighbor, so it dies in the next round. Then it's the overpopulation rule, that if there is more than 4, the cell dies. So when this cell is evaluated here, it only has 3 neighbors. But when this is evaluated here, it has 4 neighbors. Actually 5. So it dies by overpopulation. And then, right, and we see, and then the other one up here died because it was alone. It only had one neighbor. And yeah, and we always look in the in the tiles next to our cell. So each cell with 2 or 3 neighbors survives. This is about how many, right? 2 or 3 neighbors. Right? Yeah, okay. So you only, the cells, nothing changes if you have at least 2 neighbors or 2 or 3 neighbors. And in this case, we see here that yeah, this cell has 2 neighbors, so it survives. But this one dies. There's only one neighbor, and this one dies. There's only one neighbor. But there's a condition now that we haven't seen so far. A rule. So these are the rules that kill cells, pretty much, or like what they survive with. And then we have what's happening when things are not populated. So, So how did they spawn? So, right, each cell with 3 neighbors becomes populated. So, if there is a space in the grid that has 3 neighbors, then a new cell appears. So here we see in this space in the grid there is 3 neighbors, and so then the cell appears. But then each of those neighbors have no neighbors at all. So they all died. But in the next round, also this one will die because it has no neighbors. And we can just quickly. So these are the rules of the A Game of Life by John Conway. I think he passed away recently, actually. Let's see. Yeah, he passed away last year. John Horton Conway. April 2020. English mathematician, fun. He did invent quite a lot of stuff. What did he die from? I wonder. Oh shit! Of course, COVID. Isn't that great? Well, that's a little bit sad. So, well, he did leave a lot of legacy behind. So if we see, so they people have actually also named these kind of things. So yeah, let's see. Yeah, this one. No, it is. Yeah, it's so. This is a glider, right? Yeah. So this kind of item, it has been called a glider. Let's see. Can we? Yeah, there it is. is the smallest, most common, and first discovered spaceship. Spaceship? Huh, that's a fun name. Uh, it was found by Richard Guy in 1970, while Conway's group was attempting to track the evolution of the R pentomal. Oh, that's so this anyway. The glider is it's used to mean spaceship. Oh, interesting. Is this artifact or like this automaton that we start with in this version of the game here? And actually, what happens is if we just evaluate the rules from by looking at it, we see that so this cell is going to die because it has one neighbor. This cell is going to survive because it has three neighbors. This cell is going to die because it has one neighbor. This one is going to survive because it has three, and this one's going to die because it has none. But then some of them are going to be spawned. And what was the rule? I forgot that spawns. Each cell with three neighbors becomes populated, right? So once they've died, so this died, and this died. So these two are the ones surviving. And was oh, I already forgot. What was it? Three. Uh, ah, yeah. I'm guessing that how it works is probably we have to have like we have to evaluate everything in one go. So we have to also evaluate these empty cells here. Um, so there's nothing to be born here, but then let's see some of these have three neighbors. So this one has three neighbors, so a new cell is going to appear here. This one has too many, so nothing's going to happen. So let's see. Let's just go to the next round. And yeah, exactly as I said, this one got populated, and this one I missed. Yeah, I was gonna. So basically, if we keep going like this, evaluate everything in every round, we see that actually what's happening, why this is called a glider, is that it keeps moving. So you see now 10 evaluations further when we keep going. So if I press play here, we see that it will never stop moving. It will continue moving like this forever. So if I stop it here and I create something here random, let's let's make some random things here. Let's see how all this will interact with our friend. Oh, okay, everything died. So we only have this stuck in a endless loop. But maybe you got the point so far. And let's see. So why is this why this was important to point out? Because I remember when I read this, I immediately realized by looking at the rules that this is some sort of like cellular automaton kind of game. So what happens here is that we have 100 octopuses arranged neatly in a 10 by 10 grid. So we have a grid, and that's where the similarity begins with the cellular automata. Each octopus slowly gains energy over time and flashes brightly for a moment when its energy is full. Right. Similar to, like, you can imagine similar to this, like each block gains energy over time, and then they become yellow, something like that. And then in the next, so if it flashes, so I'm guessing in the next, after it flashes, then it goes back down to zero. Although your lights are off, maybe you could navigate through the cave without disturbing the octopuses if you could predict when the flashes of light will happen. So then basically we will use the octopus blinking or flashing as lights instead of our own lights, so we don't disturb them. So each octopus has an energy level. Your submarine can remotely measure the energy of each octopus. I just realized my stream category is music, but that's not true. Let's make this advent of code day 11 Python with left. Um, so I realized the stream doesn't really have a good name. Is Left Filipakis live stream? Okay, thanks. So let's rename this to Advent of Code Day 11 Python with Left. Come and hang out with us. No expectations. And I want to. Can I have emojis? Yeah, I can have emojis. And let's change the type from music to what is this? Strange entertainment, education, maybe, or science and technology. I don't know. So yeah, maybe science technology. But I guess it's technology, or maybe it's educational. Hard to know. If it's a bit of both. Let's well, write in the chat what you think it is, and I'll change it afterwards. Is it science technology or educational? We'll figure it out as we go. Thumbnail. Can't bother now. Playlists. No, it's not made for kids. Although I'm not probably gonna be swearing that much. There's no paid anything. Never used this thing before. Stream language. Let's take English. I'm starting this in English, but I actually I'm originally, or I mean, I am Greek, so we could do this in Greek as well if it begins to make sense. Title description language is English. Let's go back down here. And caption certification. I don't know. This is becoming too complicated now. Standard license. I don't know what that means. Hopefully we'll figure it out. Okay, I'll save this. So it has a little bit more interesting name, at least if somebody, hey, welcome on board. I'm gonna also write something in the chat. I can see the chat, so that's pretty nice. Hello, everyone. Welcome on board. Perfect. So let's get back to the puzzle. Yeah. So now we have let's see. Right. Yeah. So now we have we're being explained what the octopuses do. So they are arranged in this grid, and they gain energy over time. They flash for a moment, and then they go down in energy. So we need to be able to predict when they will do that, so that we know where there will be light, and then we can navigate our submarine in there. So let's see. And the reason being that we don't want to use our lights because they piss off the octopuses. So each octopus has an energy level. Your submarine can remotely measure the energy level of each octopus, your puzzle input, for example. All right, yeah. So yeah, we're also given at the end of all this thing, we're given a puzzle input. I can already open this. So this is, okay, well, that's pretty small. But this is, custom for every user that, everyone that tries to solve Advent of Code. So if you try to do it yourself, you'll have a different input to use. So you won't be able to just use my answer in the end. If we actually reach an answer ever, I tend to talk quite a lot. So let's see. Right, so this is the initial example here. That's similar to the input that we will get later. So the energy level of each octopus is a value between 0 and 9. And we see here, so each number here is an octopus basically. And you can see there's no zeros right now. But you can see these like ones will probably become 0 actually, yeah, let's see what it says. Between 0 and 9. Here, the top left octopus has an energy level of 5. So this one has a 5, and the bottom right has a 6. Okay, yeah, and so on. So you can model the energy levels of flashes as flashes of light in steps. During a single step, the following occurs. First, the energy level of each octopus increases by 1. So in each in each round, every octopus gets a +1. Then any octopus with an energy level greater than 9 um, flashes. Okay, so if they reach 10, they flash. This increases the energy level of all adjacent octopuses by 1. I got the hair in my mouth. So this increases the energy of the of the adjacent octopuses by 1, including octopuses that are diagonally adjacent. So everything in the grid, every octopus in the grid increases, right? So in the neighborhood of the grid. So this one here will affect these 3 above, these 3 on the side, these 3 on the side, and these 3 below. So let's see. So when they flash over 9. So whenever they reach 10, they flash. And they add +1 to all their neighbors. While also in the same round, all of them gotten +1 already. Including octopuses that are if this causes an octopus to have an energy level greater than 9, it also flashes. So in the same time, for example, let's see if we can find some here visually. All these 8s will become 9s in the next round. So let's see. So this one, for example, will become, this one will become 9, and let's say it explodes, or like it shines, and this will be 8, but because this had shined, this will become 9 as well, so this will shine too, so then it propagates, and then actually a similar effect might happen to this one up here as well. So this process continues as long as new octopuses keep having their energy level increased beyond 9. An octopus can only flash at most once per step. So if they've already flashed, they are not going to flash again. And finally, any octopus that flashed during this step has its energy level set to 0, as it is used, or it's used all its energy. Okay, so if they go over, when they're gonna go over 9, we basically reset them back to 0. Adjacent flashes can cause an octopus to flash on a step, even if it begins that step with very little energy. Adjacent flashes can cause an octopus to flash on a step, even if it begins that step with the very little energy. Consider the middle octopus with energy 1. Wow, my brain is not functioning now. Adjacent flashes can cause an octopus to flash. So neighboring, if something flashes around, then can cause an octopus to flash on a step, even if it begins that step with a very... okay. So if enough octopuses flash, right? Oh, this is the example, right? Yeah. So they are all going to flash, and they're going to change their neighborhoods. But this one in the middle is 1 right now. But as you evaluate all the all the octopuses in the grid, you realize that this one keeps increasing. So from all these interactions here. After step 1, it becomes like this. Yes, exactly. And then step 2 continues. Everything is +1. An octopus is highlighted when it flashed during the given step. Right, yeah. It means like in the examples. Yeah, sure. Okay. Here's how the larger step above progresses. So they take this example that we had up here, and they start running it over a few steps. So we have before any steps is the beginning, and then step 1. Some go to 9. Nothing is exploding yet, but now the party begins. Things are exploding, and you see them like this. It would be nice to try to actually visualize this, animate this when we start solving it. So that would be pretty cool to see like every step. So I don't really have a great idea yet of how to solve this. They give us more examples, but we got the point. And then there's like after 100 steps, there have been total of 1,656 flashes. So that's not trivial. You could argue that you can do this with pen and paper, but that's not very trivial. So here we'll have to, yeah, that's why I'm gonna use Python to try to solve this problem, but you always need to, yeah, use something um, like a tool that you're comfortable with. You could solve it with Excel probably, for all I know. Um, I don't want to think about that. So given the starting level, energy levels of the dumb octopuses in your cavern, simulate 100 steps. How many total flashes are there after 100 steps? So we want to do the same pretty much as they did here, but with our own thing. Usually what I do, input, usually what I do is that I take the example input and try to work with that first. So because that way we can know, at least when we get the correct result in the end. So if I manage to develop something that will show 1656 flashes at the end at 100 steps, then I know that it's probably correct. And then I can try to run for my own input, which is the one we got from Get Your Puzzle Input. And then I'll submit my answer. And this is because if you submit too many answers, after a while they increase the added delay, so you can't submit answers too often, which is probably there for good reason. So you don't just randomly try all the numbers from 0 to a million until you get a correct answer. So, but it's also a little bit annoying. So I'm going to try to not have to answer a lot of wrong times. So let's begin. Let's see. I usually use Visual Studio Code. I already seem to have open one. Right, but I don't want to use this one. I want to use a new window and put this here. Let's perfect. I have it a bit supersized. And I think actually, let's see, I think I have, no, it's not here. Okay, never mind. So I'll take this one here. I actually tried to do something for day 12, but I didn't have too much time to solve it, to spend to proper amount of time to do it. But so what I'm gonna just do here is, yeah, just push this to GitHub. Let's see, how does it look like? So there is some things modified here. Oh yeah, I add the library. Yeah, I'm trying out this, so I can add everything. It's okay. Perfect. So I can add everything and just commit this to, say, let's see. I like to put some emojis here, so I'll put this one. There was an attempt. Let's make this like this, and push that. Let's see. Yes, I don't have the branch. I'm gonna make this. Perfect. So now I want to go back to my main branch here. I don't need this anymore, and I want to create. Let's see, actually. Right. So I've also created some tests here. This is not going to be useful, but these tests, because in the beginning I was very ambitious and I started creating a entire library of to solve Python library to actually solve, or like, not exactly solve, but like build the submarine functionality. And I quickly realized it takes a lot of time to develop all this, but it's on my GitHub page, so there is something to show off for, and it's actually pretty neat. But we're not going to develop this further right now. So let's make a new branch and name it left day 11, I think. Yes. So on day 11, let's see. So we need to add a few files. Can take the outline away for now. So we wanna add a new data file. in here. So I'm gonna name this file day 11 puzzle 1, and I'm gonna paste here the my input, this one here. Perfect. And then I'm gonna make a new solution file, which is going to be called day 11 IPy notebook. Perfect. I like using Jupyter notebooks. Quite nice and neat thing to get up to speed quite fast. So let's see. So I have a kernel that I'm using, Advent 2021. It has some interesting, good libraries to help us with this task. And let's see. Let's let's start reading the file. And actually, I can start with that. With open the file name. What was it? It's one folder up. It's in data, day 11, puzzle 1, as F for file. So we want to read all the lines from this one, and we want to read them into a variable, maybe input data. So if I run this and we look at input data, we'll see that it has the strings, but it also has things we don't like. It has this new line character here, which we don't need, and these are strings as well. So we're going to make this a little bit more cool. So there's this nice library called NumPy. So we're going to use NumPy for this. So how I'm going to use... Ooh, that takes a while to import. Oof, that takes a while to import. 8 seconds. Wow. So we have this. We have our input. I'm just gonna be printing it here so that it's also more visible to see what happens in each step. Actually, I like to have that. Helps me have it a little bit more central here. So let's see. Yeah. So we want to have this as a. We want to clean it up first. So to clean it up, what I'm going to do is I'm going to run through. I'm going to do what's called list comprehension in Python. Run through the list in a one-liner kind of thing, and clean a few things out. So I'm going to say for row in a row. Row for row in input data, and I'm going to do here. Replace the backward slash and character with nothing. So if I just run this, you see that it just basically what it does, it goes through every row, and every row is a string. So it reads the row, and it performs a replacement operation on them to remove the backward slash n string. So let's see. Actually, what I'm gonna do as well. Now I realized I'm gonna put my GitHub repo on the description here. So that people can find it if they want. So yeah, let's go back here. So now that we removed this, we still want to do something cool with those. We don't want it to be like this. I would like it to be an integer block at each location. So let's do. Let's see. I think we can do split. Let's try this one. No, damn it. Okay, but I can nest a list comprehension actually. So I can mess things up a little bit. Should I? That's gonna look a bit ugly. But let's do it for now. Why not? So what I'm gonna do is I'm gonna create another list comprehension on each list row that the initial list comprehension performs the cleaning operation on. So now this is going to be the input for the next deeper level of our list comprehension. So let's say I want to say this is position maybe, or grid as, no, let's say, I'll name it position for now. I don't know, I don't have a better name. For position in row, what we want to do, what's this going to do is it's going to be running through each one of these digits as strings. Sorry, in Python you can actually iterate through a string as one like character at a time. So this is it receives this string, like basically this string, but with a cleaned ending, and then it will basically go through each of these digits. So let's do and what we want to do. So this one here, the pause, is going to be a digit. Maybe I can name it octopus actually. It's maybe more reasonable. Octopus. So this is the position of each octopus basically, or like the energy of each octopus. Or so let's maybe do that. Octopus energy. A bit verbose, but it's good to be able to understand what we are reading. Even though this is a nested list comprehension, which makes things much harder. So so what we're gonna do is we're gonna assume that each one of those is always going to be an integer. So I'm going to force it to be casted into an integer. I kind of like to give it, oh, that's not very Pythonic here, but just give it a little bit of breathing. Never mind. I'll just make it how it should be so people don't get... So if we run this, you'll see that each one of those will become a digit, hopefully. Let's see. Yes, exactly. So now we have a list of lists which contain a position of which contain basically the energy of the octopus in each position. So now why this is cool is because is easy to navigate. So if I save this into grid, grid, and say just grid here, so we get to see how it looks like all the time. No thanks. We can do this. So in Python you can access certain you can slice arrays and access particular locations on them. So I can say with the square brackets here, I can say I want the 5th row, let's say, which is going to be actually the 6th row because it starts from 0. So it's 1, 0, 1, 2, 3, 4, 5, 6. And let's say we want the 3rd element, which is actually the 2nd because it also starts from 0. So let's take the 2nd element. So we should be seeing that it's a number 4. So if I run this, yes, it's correct. It's wrong. Sorry, I took this one, I guess. Wait. So this is the 6th one. Yeah, that's correct. I counted them wrong. So this is the 6th row, correct? We took number 5, index 5, but is it? Actually, I can illustrate that a little bit nicer with just 0, 0. So this is the top left corner, so that should be 5. Perfect, that is 5. And let's take... yeah, let's take... oh wow, brain damage. So the reason for doing this is because now we can access every piece of the grid nice and fast. I do realize I did import NumPy to do like something like this, but maybe we don't. Let's see. So now, maybe we won't need NumPy for now. So what we want to do now is we want to be iterating through every part of the grid. Uh, I see. So what we want to be doing is we want to be able to evaluate the entire grid all the time. Instead of if so I'm trying to think of a smart way to and instead of looking through every position in the grid all the time, to just know which positions to look at. So maybe we can have like kind of a compressed view of this grid instead of let's see. I can't really think of something else. So we can okay. How we're gonna how we're gonna solve this for now is that we're gonna be running through every step. So we're gonna have multiple loops. In every step, everything gets +1. So let's try. Can I do grid +1? I think not. No. Okay, so that's why we actually do need NumPy. So let's try, because then we can actually add a scalar to an array. So let's make this into an array. And this is going to be grid. Let's see. Perfect. I see one problem. So I think this is not a regular array, or the way we would like it to be. Can I try this? It works. Okay. Perfect. Okay, then that's fine. Then we want grid to become this, basically. So maybe I can keep it here. So let's do grid. We can see. Let's try to see like a piece of it. Can I do like this? Yes. Perfect. So now, right. So this is 0, 1. It's here. Number 7. This is octopus 0, 0, 1. Okay. We can also address them like this. This is kind of their name, I guess, their location. And it has an energy level of 7, and that's what we see here. So this is how you access elements in NumPy arrays. And I just wanted to make sure that we can do this. So let's do an initial loop for step in steps, or like range steps. So what is this going to do is we're going to define steps here as let's say 100 for now, and yes, or maybe we take something smaller so we can compare it. Let's take 10 here. 10 steps, and what I will also want to do is to take the example input instead. So it's this one here. So what I'm gonna do is I'm just gonna quickly make this. Let's see. How can I bake this in a nice way? Yeah, I'm going to add it here. Example. So when you do these double quotes in Python, it makes them. You can have like a multi-line string, which is really nice. So I'm gonna paste this here. But I actually don't even want that exactly. Yeah, never mind. I'm gonna remove the multi-line string thing for now. So what I'm gonna make this into an array. I'm gonna move everything in here, and then I'm gonna make multiple cursors. This, at least in Mac, you can do with Command and Alt option, or what's called. I have a different keyboard here. It's a Command option, and up or down arrow like multiplies your cursors. I don't remember if this applies to everything actually. Let's try. Can I try like as a test, like text editor line? or I can, yeah, online. Let's test this one. Yeah, whatever. I just want to see if I can create a text. Can I create multiple cursors in here? Whatever. Can I? Oh no, it's not. It's not giving me. Oh, come on, just a simple. Yeah, edit pad. What is this? Create a new note. Perfect. Can I create multiple cursors here too? Maybe with this one? No. Okay. Just making sure. So I think yeah. So it's I don't know whose feature this is. If it's Mac or VS Code. I think in this case it is probably VS Code, but I know that Mac has this feature where you can create multiple cursors with this command option thing. Somebody can test it further. So let's do, yeah, let's add these. So basically what I'm doing is I'm creating, yeah, and I wanted this. I want to create this as an array already, so I don't need to parse it as an input. So I'm going to name example input, this one. And what I'm going to be doing is I'm just going to be, in this line here, I'm just going to be overwriting the input data with the example input. And the reason is I can comment this out when we want to use the real input directly. So if I run this and this, now you can see we got the other input. For a moment actually flashed something. Ah, yeah, it flashed this one, never mind. Right, so if I keep running, then now we're using the example input and everything goes through fine. The replace now doesn't have anything to remove, so that still works, is fine, even though these don't exist. Replace will only I operate on what it finds. If it doesn't find something, it just won't do anything here. So this is cleaned and nice, and then we can continue here. We don't need this anymore. We can make our grid nice NumPy array, and now let's do the looping. Yes, so for 10 steps, at each step we want to basically give our grid, and let's actually make a copy of our grid as and say live grid, so we don't operate on the original grid for now, so we have a clean copy, so we don't need to run everything all the time. So yeah, so the live grid will be, let's try this, will be increasing itself by 1 at each step, and so once this happens, we are running a loop. So we're going to be running 2 loops, 1 per row and 1 per column. So for row in grid, live grid dot shape 0. Shape is basically returns the yeah, we can do this here. Grid dot shape, it returns the shape of the array, and this means it's an array that is 10 by 10 in dimensions. So with 0 we take basically the first side of the array. So the reason for doing this is because maybe in the future we will have different sizes of arrays. You never know. So it's good to be prepared, and this will work for any kind of array right now. So we are iterating through every row, and now we're iterating through every column in livegrid.shape. One is the second element here, so that's the number of columns. So for each item in this array, we wanna I see something. There's a special condition now that we have to keep in mind. When we're looking for example for neighbors for these ones, we can only look below, we can only look above because there's nothing. So if we try to look above, we'll get an error. So let's try to let's see how should we solve this one? Yeah, so the way we're going to solve this issue is by not by looking at this at the size of the arrays and figuring out, or actually, yeah. So let's say if our row is 0, then it means we are up here, and actually I have a better idea. If row is in this array, and this array is going to be 0, which is the top, and the maximum. Okay, and there's another mistake I made here. This is actually not going to be looping through anything. Is going to be just one number, 10 in that case. Range basically takes the n input. Let's see if we get some. Yeah, so it takes an input and it produces a sequence of integers from that input, and by default it adds a step of 1. So what will happen here is it will create a sequence of integers from 0 to 9 because the input is 10, and the same here as well. It will create, because the input is 10, it will go from 0 to 9. If it was 100, it would go from 0 to 99 in that case. And then we want to do the same here. Otherwise, because this loop will not do anything. So let's see. Yeah, right. I'm just so now what is happening is that we want to make sure that there's some edge cases, and we want to make special conditions for them, and that is when we are in the first row or the last row, because we can't see above or below. So we need to say this one as well. So if the row number is 0 basically, or that. And in means that if the number that the row variable gets in this iteration is inside this array, and basically this array was going to be just two things, 0 and whatever this is, which is going to be 10 for, I think, for this entire puzzle actually. So if we just say pass here for now, let's not do anything. And if the column is in, again, I think it applies the same thing. But now is with the column shape. So let's say, yeah, if we are here in the leftmost side or the rightmost side, there's nothing to see left and right. So what we're gonna do here is let's see, yeah. So in here we're gonna say just avoid looking up. Wait. Oh, there's maybe, yeah, we'll see how we're gonna break these because now this is two different cases that are quite different when we're adding them in here. But I've only looking outside of the grid, up or down, and then we're gonna put this here. If we're looking outside the grid, left or right. Yeah, perfect. So I'm gonna look at these conditions later. So let's so let's sketch out the standard operation of our range. Sorry, of our of our loop. So for each step, we want to look at every. Okay, there is one thing actually that I realize now. We want to be doing this in each step over and over again until there is no more changes. So we're going to do this with a while loop, while changes, and do this, put all this in here, and I'm going to say changes false, true by default. Because already in the beginning we have one change, which is the +1, and then this is going to be looping until while changes are true, and we don't want let's see, how are we going to be evaluating if our grid changed? Maybe we keep uh, previous version, or like current grid stat version, or state is live grid. And I think in NumPy we probably have NumPy docs. We have a way to compare if two, yeah, actually it's probably a simple equality sign, I guess. I want to compare if two, yeah, which version NumPy are we using? If two arrays are the same. Version 121.1, okay. So that's here. Installation, no, I just want the, no, I think I'm in the wrong, I want the reference manual, but for users, what's that by, you know, API reference here. Array objects, we have a, is this considered a thing in the array? Yeah. So we have the equal, maybe, let's see, equal, no, EQ maybe? Yeah, okay, so it's, it has, it's defined, perfect. It has a definition of figuring out if two things are the same or different. So let's try to perform a test and say, so we get a copy of this of our array, and after we run through this, we want to see if our live grid is equal to the current grid state. No, not current, sorry. Let's make this a little bit more obvious. So it's previous grid state, actually. So if that is true, then changes becomes false. And that is because there were no changes. So now the loop is not going to come in again, and this is going to go a step further. Right, so yet we have not implemented. So now we have kind of the system to loop through everything and update the state of our grid. What we don't have is actually the actions we should be performing at each step. So if we look at the rules again, the is these three here. So yeah, so the energy level of each octopus increases by 1. We've implemented that basically. That's I don't need this either. That's this one here. At every step, basically the grid upgrades itself, updates itself with the +1. And then we have the second rule, which is that octopuses with more over 9. So let's leave this here for now. Let's comment this out for now completely and say if grid. So let's take octopus. That is the one that we're currently looking at, and this is going to be in the grid row, column position. So we get a number, an integer now. Yeah. Let me think. Yeah. So this we want to put up here, right? So so what we'll do here is now that if this is over, if the octopus level is over 9, then we want to set the no, sorry, not grid, but live grid. So we want to set this to 0. So if the octopus octopus flashed. If its energy level is over 9, it goes to 0. So that's the first condition. Let me move these a little bit further down. Yeah, because that's not relevant yet. So now that's if it's not. So if it's less than that, nothing should happen. Let's see. But if it does flash, then we need then we need to go to all its neighbors and add +1. So that's where this is going to come in, actually. So because now we want to test every neighbor that is on the sides here. So we want to test every neighbor that is -1 on the left, +1, -1 above, and +1 below in the grid. So let's see, check or like update octopuses. Let's see, above. So this is going to be live grid like this, or a row -1, and on the same, and column. Okay, in column we want it to be -1, 2. So we can do with this operator here. I don't know if that's standard, not by Python, or how to write this nicely. I kind of don't want to write it compactly because it becomes harder to read if it's not already. So basically what happens with this full colon operator is that it NumPy will look for three, in this case 3 pieces on the grid. Let me check. I just realized the battery in my laptop is not charging fast enough. 62%. Did I burn everything? I don't hear audio. That's not good. Let's see our friendly cat here. What happened to you? Maybe I should restart, hopefully. Now I can hear something. No? Oh no. But I can see that you can hear me, actually. You can also hear the music. It's only me that can't hear it. I wonder if that's a problem with this one. Let's see. Where's my mixer? My mixer is... let's quit and restart this. Ladiocast. So I'm using this software too. Oh no, it's not working. Shit. Yeah, that's strange. I'm gonna try this again. Ladiocast is this. Oh, it's still not working. Damn it. That was really nice. Because the problem is that I cannot hear the music anymore. That's a bit sad. And I think that I did something when I unplugged this. Maybe, okay, I'll pause the stream maybe a little bit and try to fix this real quick. Can I just do that now? Yes. Okay. I believe we're back. So I just had to restart my sound card real quick. But now I have music back on. So yeah, so hopefully that's not a big problem. I'm playing this video in the back to give some... I hope the sound is good as well. But yeah, I play this in the back to give some background sound to a soundtrack to our evening, this wonderful Saturday today. Mm, right. So what we're doing now is we're giving plus ones to everyone around here. So this updates the octopuses on the above grid, so -1. And then we need the same for update octopuses below. So that's gonna look the same, but instead of row -1, it's going to be +1. And then we have update octopuses left and left and right. And then we do the same here, and basically we flip things around now. So now it's going to be from row. Yeah, we're gonna fix the column, but we're gonna be changing the row. So we're gonna be, for example, look, if we were looking at this one, now we want to fix the column to 0 and go from row from 1. So this is 1, 2, 3, and then the same from that side here to update those if this would become over 9. Let's see. Right, yeah. So let's do this from -1 to +1. So the only thing I am curious about is, let's try this out, is what's going to happen if this becomes grid -1. Yeah, I think what happens is, let's see. Yeah, it brings, Python can do this actually, which is a bit silly. It actually goes, it loops around. Oh, I wonder if we do want that though. I wonder if we should have. It does. They did not say. So what happened? Let's test this out with. Let's see some example. Maybe they will show what happens if something explodes on the corners. Does it? How do we tell now? Oof, that becomes quite tricky. Yeah, I think it did actually. No, this already. This had this one here. They don't specify, so I'm gonna assume that because like what happens if this explodes? Does it affect these ones? Because basically, what I think what this is called is it like it's like when your universe kind of loops around. Things called the torus, shape, toroid or something, toroides in Greek. Let's see, it's so almost. I think it's not exactly what I was doing. Yeah, this is toroid function. Yeah, this I got it. But what is the difference between toroids and toroids vs a torus? What is torus? What's the difference between toroid and torus? Wikidiff. Interesting. I didn't know Wikidiff exists. Torus is derived from the term of torus. Okay, so it's pretty much the same. Or toroid and torus is a surface generated by a closed curve, especially a circle, rotating about but not intersecting or containing an axis in its own plane, while torus is a topological space which is a product of two circles. That went a bit. I see. I used to remember this. Yeah, okay, it's torus. Yeah, torus. So what was toroid? That's I kind of missed. A surface generated by a closed curve, especially a circle, rotating about but not intersecting on containing an axis in its own plane. Yeah, I can't. I don't have that much brain power right now to process English texts on math. So let's go back to simple brick and mortar programming here. So basically, let's start with a torus and we see, maybe we evaluate the result that we get. So for now, we're not gonna care about this. We're gonna comment it out. Um, Basically, what this will do eventually, if we do need it, is to make sure that we don't loop around in the edges of the map, so that we don't, if something explodes here, it doesn't affect anything here. But I get the feeling that it should. So let's leave it like this. So now we want +1 here. And I think this should theoretically work. Let's give it a first run. So do we need anything else? What's the third thing here? Final octopus that flashed during this step has its energy set to 0. Okay, that we've already implemented. As used. Okay. I wonder if this should happen. Oh yeah, but I'm trying to see now. Maybe we have some sort of gap in the logic here. So final octopus that flashed during this step had it. So it sounds like we should set the step to the energy to 0 now, because I'm getting the feeling that in this loop here we should update everything, and then once everything let's test it out, whatever. Let's see what we get. So we already got a first error. Perfect. The truth value of an array with more than one element is ambiguous. Okay, so I think there is NP equal. Yes, so let's see what this does. Two arrays, if the shape is not the same, okay, now they're gonna be the same, no worries. So it returns an element-wise operation. Yeah, that's what we want. Okay, element-wise is that it tests each element inside the grid in the array one-to-one against the other, from one to the other array, to see if they are actually equal. So let's np equal, let's do this here instead of this. Perfect. So because the problem now here was that it's trying to perform like it basically returned, I think the result of this equation, equal operation, was another array with true and false everywhere. So let's just test this like this, just for visual. Yeah, exactly. So this is hard to tell. So everything has changed, as you can see. So this is true because everything changed. So this that is strange, actually, because we want. Okay, I see one issue here. So this, it got +1 out here. So this grid. Okay, let me think about this for a moment. So the problem is here that this will be, in the first iteration, this will be true because there is no, well, there should be some changes though. So this should be false because in the first, this is running through everything once and it's fixing these effects on the octopus universe. But maybe no octopus became exploded. Maybe no octopus exploded. So in the first round, let's check in the solution. Actually, yeah, that is true. So on the first round, no octopus explodes. So what happens here is that basically we increased. Yeah, that's so the okay. So what I'll do, what happened here is that this operation does not know that we already changed this up here. So what I'll do is I'll perform this twice, once out here and once after this one here. So now it should work. No, damn it. Index 10 is out of bounds. Yeah, okay, so okay, we run into this problem after all. Right, yeah. So what happened basically is it's trying to look for 10 column or row. What is it? Row, I guess. It doesn't matter. In either case, 10 does not exist. It goes all the way from 0 to 9 and 0 to 9. So we just have to see here. So we actually have to do this. We have to make special conditions for when we're reaching the edge of the grid. And how can we do this nice without like copy pasting all this? How can we do it in so yeah, let's do it crude, the crude way first, and then we'll figure out. So for this is for the rows. Oh, sorry, wrong shortcut. So in case the row is 0 or 2 or like too much. Okay, I'll have to break this one down as well. Okay, let's make it super crude and we fix it later. So if row is 0, do something, pass if else if row is equal to the end of the grid. Also, yeah, so let's put this here. Do something else. Otherwise, look at everything, which is this. Let's see. So this affects. No, okay. I have an idea actually. So yeah, so we're gonna perform a min and max operation instead. I got an idea. So max, let's see. So if we have maximum of live grid dot shape 0 and no, sorry, minimum. Either that and that. No, that did not work. Wait, what? Oh, wait, how does min work? I thought it was. Ah, okay, it needs probably needs an array here. Yeah, okay. No. So the issue now is that they're both equal. So we want to do like this. Yeah, right. So because the shape of the grid is 10 by 10, but we're looping from 0 to 9. So we want this to be 9. So this is going to be our limit, and this is going to be our current row. So if I take this, maybe like this is nicer, and do like this, take it away from here, put it back in, let's see, I can remove all these. And we can say, I can actually remove this one as well. And we can say here, that makes things a bit nasty, but so I put this here. And we will always take the smaller value between row -1 and the, let's see, am I thinking this correct? Yeah, we want to take the minimum value between the so this is a case where if we reach this at the edge here, we don't want to go above or outside. So we want to, in this case, want to take 0. Yeah. So well, that makes it a bit more complicated to write in a simple clause. So we want to take, let's go back here again. So let's print our things. So we have row is row -1, where we are right now, just to illustrate, and column, or here. Oh. Column is going to be column -1. Right, so we have 3 and 8. And in this case here, so we want to take, let's say we put in, let's say we start with row 0 and column 0. So we want, let's see here, let's print some more things here just to illustrate. Fixed row, which is the fixed result that we're looking at, we wish to produce, and print fixed column, which is the fixed column we wish to get in, so that we don't get minuses and two high pluses. Right, so let's go here. So we want to take the minimum. So we have for the row, we want it to be the maximum between the row and 0. So we never want it to be -1. So if I run this, it should be 0. Perfect. Even though the row is -1, we want to fix it to 0. And the same for the column. So we're going to do that here. And this is saving our left side. Let's do column here. Perfect. So, but then there is still a problem. That is, if this becomes 11, what happened here? Oh yeah, it's -1. Sorry, that was confusing. So let me remove the -1s from here. Yeah. So if it's 11, we want it actually to be 0, or not 0. Sorry, but the maximum number of available, let's see, available columns or rows. Yes. So this should not go over. So then we take, this is the maximum value here, and then we also take NP minimum of what the maximum was, together with, let's fix this. I think I copied this one. Yes, perfect. So this is for the column, so I'm going to take side 1. So we don't want it to grow more than whatever the size of the grid is in columns, -1. I think like this, maybe, and this. Yeah. So if I test this, yes, perfect. So now, so if I make this, I'm going to keep the -1s here, so we are consistent with how it's going to be used in the code above, actually. So if it's if the column number goes to 11, it will still be restricted to 9, so we won't go over it. And if it becomes, I don't know, 0, it won't become -1, but let's put -2, for example, it still stays to 0. So we're bound in between these limits. So I'm going to just copy paste this up here and change this to 0 and this to row. So now this should also apply to the row. So we see, let's put something large, 12 and 14 for no reason. So they actually become 13 and 11 because, yeah, we index with 0. So in this case now we see that the operation we have performed here limited our rows and columns to the actual size of our grid. So it's stuck with 9. So let's take this code here and just put it back in our operation here. So let's see. So in this case here, we want to have, it looks pretty ugly. Yeah. Let's name this. Oh wow. let's make this a function actually. Let's make this a function to make it a bit nicer, and let's name it define grid limits, and we give an input as um, position, which is an integer, and it returns an integer, and that's going to be basically okay. So we want to limit the position, and based on the grid shape. So grid shape is going to be also an integer. And instead of using this, I'm just going to say grid shape, and we'll do -1. I should probably document this so that we can know that later. So let's do that now. So this makes sure we abide by the grid, by the available indices on the grid, so we don't run out. Position is current position on the axis of the grid, and then this shape is actually okay. We're gonna make it even a bit nicer. Not grid shape, but let's give the grid as an input, and or yeah, let's give the grid shape. Never mind. We don't need to do things right now. Current position of the axis on the grid. Maximum position on the axis of the grid, on the current axis of the grid, on the current axis on the grid, and then it returns corrected position, bound, constrained inside the grid indices. Perfect. Let's do this, and that should return this actually. Sorry, return. There's more documentation than code. So let's go here and say this is our function now, is grid limits, and we say row -1, and then we take the grid. Let's see, maybe we can make this a bit nicer as well. Live grid. I think we can just do this once up here. Grid rows. Do this live grid dot shape 0. Grid columns, live grid dot shape 1. So then we can also replace this here with grid rows, and this one here with grid columns, so it becomes also a little bit more obvious or more consistent to what we're doing. So grid, and also the grid is not expected to change shape as we go through it, so we can do it like this. So this is the grid rows that we want to limit the row to, and then we want to do the same for everything actually. I wonder if we should make a function from that as well. Yeah, let's do that. Let's make a grid update function. So def grid update, and it takes increment as which is an integer, and the grid. which is an ND array, NP array, sorry. And it returns. It returns an integer. Yeah, so let's directly update the instead of updating the grid itself, just return the new number, the new. Oh, and we need wait, and we also need to know the position. So I'm gonna actually make this equal to 1 by default, and then in case we ever want to make it more than 1, the grid should be an NP array, and then we have a row is an integer, and column is also an integer. And let's make this up. So now we want to take this in, basically return this so grid, and we will operate with grid limits. So we give it a certain row we want to update. I see a little bit of complication here. So how do we make this nice? And that's also not like the problem of making everything nice is all before we've even implemented anything or like anything that actually runs is premature improvements or refactoring and optimization. So not cool either. But what the hell? Let's make this nice. Let's see. So we want to update a certain position on the grid, which is given. So we want to figure out. So we can do this actually quite fine. We can do grid shape as 0 here, and yeah, okay, I see what the problem is now. So we will need different functions for update rows. Yeah, okay, so let's do this grid update row. Yes, so this will take in a row number and a column number, and it will update the neighboring. Am I thinking this correct? Yeah, okay, you know what? Let's skip this a little bit for now. Maybe I'm overthinking this. Let's make this a little bit ugly, but workable. So we have the row here. Let's maybe space it out like this. So this is our row and this is our column. So we have grid limits column. This is the column, and then we have grid grid calls here, and then it's the same on the other side as well. Let's do, but with +1 instead of -1. Sorry, +1, and then we do like this. Perfect. Looks okay, I think. Could be worse. And let's do the same now for all the other ones. But I'm gonna paste them in, and we edit them as we go. Perfect. So now we wanna update the ones below. So this is going to be just +1 here. So we just look again at the same the row we have below. This one here should be actually the other way around. But let's see, because we want the range to be in rows. Yeah, because we're going to be shuffling through rows and while keeping the same column. So let's replace this. That's actually easier than I thought. Rows, I think that should be fine. Yes, that looks good. And then I can do this here. Gotta love the multi-cursors. And that looks almost correct. That should be, oh, that should be fine now. And then it's, so I can actually copy this as it is and paste it here to do the update on the right side. And we want to do +1 here. So there is one issue I suspect right now, that is what will happen when this fixes the limit. Will it update itself? So maybe yeah, because now actually I've been I've been going at this the wrong way, because now this will still run, but it will update the wrong. It will update something that has been already updated. So we actually wanted to make a skip thing. Oh, okay, so I went kind of the wrong way here. So we want what we could rephrase this to is. Basically, if the position, and here we don't want to do this actually, that's fine. If the position is equal to this one, so if it hasn't changed, then we have not reached the grid limits. So this is going to return a Boolean true false, and it will be if we have reached the limits of the oh wow, I'm going back and forth with this. Because we still want to update like I think yeah, because I think a new edge case that appears now is that if we try to update something that is out here, which basically doesn't exist, we will see we will move it back in here. So what will happen is that we will update again this edge here. So instead, we just want to skip it altogether because there's nothing to update here. So maybe the if else cases were actually pretty reasonable. But that's only a problem for these. Because these we still want to have. Okay, yeah. So yeah, so I see what the solution can be here. So we may wanna avoid fixing those, because if we are targeting, will we be targeting something that is out? -1. Yeah. Yeah, because if we're here, if we're up here, then it will attempt to go big away, but then there's nothing away, so then it will be reset to its own self, and it will update itself. So that is wrong. Yeah. So that is I was doing this wrong now. We just want to skip updating it actually. So maybe we wasted a couple of minutes on this one. Let's see. How should we go about it? I think the if else statement in the beginning was kind of okay. Even we can make it a bit cruder. Let's think. This we want because it will, or do we? Because if we are here, we still want to update these two, but not a third one. Above. Yeah, but if we are here, we actually have nothing to update, so we shouldn't update anything. Right, so basically, I think the condition here is Yeah. Okay. Let's go back. Let's go back to this. Actually, yeah. This should be like this, and this should be like this. Right. So if so, let's calculate the update on the row. If this is equal to the row minus one, if not, yeah, or yeah, I mean, I don't need to write it like this. We can write it like this. So if they're not equal, do it. Otherwise, sorry, yeah, yeah, it should not be equal to our current row, because if this returns, oh wow, this is becoming complicated. I'm not doing this the proper way. Let's see. Let's think about this again. So when we are here, we don't want anything to catch anything above or outside. So the condition here is we don't want to go -1 at all. But there is a case where we want to still go -1, and that's down here. We don't want to go in columns -1. Sorry, +1, because there is nothing. But we want to still go -1 here. And how about this one here? Now maybe it is working like this. If otherwise, do not update anything. Yeah, because yeah, I think it's fine actually. I think it's fine. Okay, let's keep it out as is now. If and then we always want to perform the comparison with this, because if the row doesn't exist, then we don't want to do it at all. If it's not equal to row, do this. Oh, there's also the no, so it's either we also need, yeah, exactly. So we'll do this finally. So not, because we want to catch both cases. We don't want to go above or too far below. So we want to make this this kind of operation. So we don't want, if the result of this is the current row or the grid rows. No, that should be fine actually. I think we. Let me think. Yeah. Otherwise, yeah. Let's keep it like this. Let's keep it like this and see how it goes. So now, if this function returns our current row or the number of rows that are available in the entire thing, it means that we're updating something that. No, wait. Yeah, yeah. Because if we are here, this will be the current row. Damn it! Brain freeze. Shouldn't be so hard. Let's think. So we don't want it to be outside of. So maybe what I could do. Oh, that's gonna be messed up though. If it goes too far out. could return two things. I could return a position and the information on if we are being fixed or not. Wow. This is only a problem for this coordinate. Yeah, actually, okay, yeah, I got it. The way we're gonna do this is we're just gonna completely avoid updating things that are so if row plus 1 is greater than grid or rows, so if it is greater than available rows in the grid, or -1, yeah, or let's do it like this. Let's see. Or it is no, there's no or here actually. So that's the only case here that we go over, right? Yeah. So that's the only case here, and the case here is that we go below 0. So we don't want that. Perfect. I wonder if that will work as expected. Let's see. Let's test this out in a Python shell. Wow, that's taken more than I anticipated. Let's do this. Do I have poetry shell? I want a Python shell that is inside my... Oh, are we in day 12? No. Okay, this is just day 11. Okay. I'm on the correct branch. So if I do here now Python, let's see. We will want to do just a small test. If 9 minus 1 is less than 0, it's false. Okay, that's good. Which means that this first operates all the computes all the conditions this way in this side. That's good. Just a quick test to make sure that things work. So this should be fine as well. And then we want here the same but for columns. So we want the column to be if it's to not be greater than the maximum available allowed number of columns. And then the same here, but no, wait, is this no, this is the wrong one. Okay, or I can fix this real quick. So this should not become less than 0, and this should be this one. Perfect. Wow, so this, let's see how this goes now. Okay, we did get an issue. The truth value of an array with more is ambiguous. Okay. So this still returns, let's see. Oh, where is that? So the problem is that this one still returns np equal, yeah, I can just run this. I think this still returns an array, so that's a little bit of a problem. Yeah, okay. Also, which iteration are we on now? Did it break in the beginning, or print a row call? It broke at the... the end, or 9, 9. Uh, that is strange. What is the status of, let's see, changes. Changes is true. Which means, and what's the step number here? Also 0. Okay, so we're in the first step. What I'm going to be doing is I'm going to be printing those in each iteration just for debugging purposes. So let's put this here. Oh, that's going to be printing quite a lot of things. So maybe. Okay, let's put it here for now. So it does go through a few runs. So it does go through everything once, and then it arrives here, where it seems like it changed nothing, which is strange. Then, because if we take this equation here, this one, and try to test, okay, we see that everything is true, which means that they are equal, which is not expected. They should have changed. The live grid should have changed as we go through this one. Oh, yes. Of course, this has to no, yeah, okay, so this is not going to run either ways. I should have fixed that. So I thought I fixed that from the beginning. So this didn't work. We want to do, then we don't care about the equal. It doesn't help us that much. So we can just do this and do, or actually, the thing like this is any. Did it crash? No, sorry. Or didn't that work? Any? Does it have to be in the? I think yeah, it has to be dot any. Yeah, maybe like this. Yeah. Okay. Any? How did I don't remember how this works actually. Any list. Let's try any. No, it doesn't have. Okay. All. I don't remember how any and all works. Let's Google this one. Python any all. Can I just get the proper documentation and not just some? Oh, I don't want Stack Overflow. Python site python.org Let's see, built-in functions. Is it here? Any? All? Yeah, perfect. Return true if any element of the iterable is true. If the iterable is empty, return false. Okay, no, we don't want any. We want to catch any false. All. Return true if all elements of the iterable are true. Yeah, okay, perfect. All. So that's what we want. So we want to, if all are true, all. Perfect. So I'm just gonna do this here instead. And why didn't this work? It has to be at the end of it, or doesn't it all doesn't work like this? No, okay. So let's do this. All. So I want all of these to be true. Then there have been no more new changes. So also let's limit a little bit how much we print here. So maybe what I'll do is I'll just put it here to show. Or here maybe in each step to show if we had. I'll just print the step, whatever. For now, let's try it out. Okay, we got some all the steps actually. So let's see where we got live grid. Let's see how it looks like. Okay, does it look like anything on the example? Did we make any progress? So we want step 10. No, it does not look the same. Maybe the same with step. No. Okay. Do we have any? We have some zeros, some nines, but it looks different. Damn it. Am I using the example output? Yeah. Let's run everything again. Let's restart and run just in case we took with us some random stuff. Let's save this as well. Oh, that looks different. I can let me remove some things so that doesn't confuse us. We don't need this anymore either. Go away. No. 9, 7. No. It's something completely different. But I just want to make sure that we're using the correct one. 548. Let's see, 548. Yeah. Damn it. Okay, this is not going right. I wonder if it is because of it does not specify that. I think they would say that if it was a torus, if it was looping around, I think they would just say that. They would say if you reach the edge, yeah, if you reach the edge, you go to like the neighbors, right? They would probably say that. But in the physical space, that it does not make sense actually that this should loop around, because in the physical space, these are the octopuses lying in front of us in this way. So it shouldn't do that. So let's see. So then I don't think it needs to be defined actually. Oi. Oh, I'm an old man. Starting to get a bit tired. It's been 2 hours now, and this is still unsolved. Let's see. So I suspect that something's going wrong with these ones. Let's try to take one step only. Let's take or let's print. Actually, let's do this. Let's print the grid in every step. A live grid. And we want to print it also in the beginning. So this is the initial. Yeah, let's do that. Oof, yeah, I didn't think about it too that well. Oh, it went to 10. But at the end of the loop, it should be, if it goes over 9, set it to 0. Yeah, okay. Yes, I know why that happened. Of course, because I print this too early. So let's do this here. Yeah, let's do this here. So if I try this again, there shouldn't be any. Yeah, there shouldn't be any. No, there is 10s. Damn it. That shouldn't be the case. I suspect that maybe this doesn't work. Let's do a count here and say, or like loops to changes, and do this plus 1. So let's also print. Let's also print the number of loops we've had. Print loops. Loops to changes. Perfect. So let's do that. 1. I suspect that this is not working. Yeah, let's see. So it's always 1. That's not good. Yeah, let's. Okay, we can comment out this one for now. So I think I did the while loop wrong. Is it while true or while false? Wow. Flow control. Let's see. I'll just switch it back and I'll just yeah, we'll just do it like was it like this? I think no, like this maybe or not. Well, not changes. Yeah. Oh shit. No, that doesn't even run once. Okay, so that was correct. Um, does it get stuck because it? Oh wait. Okay, something is a bit off here. I'm doing something a bit wrong. Let's see. Um, we can take this away for now. Oof. What is happening here? Is this being... Oh... I have a suspicion of what is happening here. This is... Haha. Okay, we're getting a copy. We're not getting a deep copy of this. I wonder... Ooh, okay. All this time we'll be using a reference object, which means that we are actually editing the original grid. So that every time... Oh, no. Oh, I've messed this up just a little bit. So let's see, how does the copy function work? We want to make a full copy of this. Return a copy, an array copy of the given object. Controls the memory layout of the copy. Yeah, I don't copy true. Yeah, because I don't want to ensure all elements within an object array are copied, use copy deep copy. I wonder if just copy will be enough for this case, since we don't have like anything nested maybe. So let's yeah, let's run everything again. Yeah, okay, now it looks like something is happening. Let's okay, that looks hopeful. Let's look at the state. Oh no, sometimes it went to 10. 971, no. Let's see. No, no, that does not look correct at all. But sometimes it went to 10, so that is wrong. It should not reach 10. So that is the problem. So it, let's see. So the, if I put them next to each other, just to make it easier to compare. Let's do it like this. Yeah, so now, what I want to check here is, yeah, I go to the beginning. 55831. Then next 65942. Yes. And then next is 880. Oh, 38. So the when something explodes, so this exploded. Oh, but it became one. It became one because I add one to the grid. No, but I printed before I add this. So it should be looping here every to find all the nines, or the like everything that is above 9. So here it missed. Yeah, so this became a 9. So this made this became a 0. So but this is not a 0 now here. I don't like that. Did it get incremented by something else? Now that's complicated to debug. Oof. What is there? I'm just taking a break, looking at social media here. nothing interesting happening. Oh, my voice is really tired now. But nothing special. Okay. That's tricky to debug. So let's see what. Let's try to figure out what happened here. In the first step, so this we don't need to compare. It should be the same. Then here, this should also be the same, yeah, because nothing happens in these two steps, except for just adding one. But then we have this. Let me just. Can I put an extra space? No, it's a read only. Okay. So here, that's what happened. This became 0. There's no zeros here, but let's see the ones. Are they at least mapping? No, they're not mapping at all. Oh, there is some zeros. Ooh. What? But they're completely off place. So this became a 1. And, or like a, why did it become a... Oh, I know. No, but we are supposed to increment. Oh, maybe if it is 0, it does not increase anymore. Or no, but that was an example up here, right? That, yeah, that all these... No, but they remain 0. Okay, that's the mistake. Yeah, okay, got it. Got it. So if it is 0, so that's another if. Oof, okay, yeah, so... Oh, damn, that's tricky. So if it is already 0, we don't want to increment it at all, actually. So can I... So the problem now with doing this is that I first have to get the value from this. I have to implement these as... Yeah, I'll make 2 functions for those, for like get row. What is it? Yeah, get row and get column, I think, because now it's becoming a bit too much. So let's do get row, and let's make this. Let me write def get row. And it will return an ND array. And then NP array. Perfect. And just pass for now. And we want an input which is the grid. And the grid is going to be of ND array type. And I keep writing ND array. NP array. And then we want to know the row we're trying to access. And I think that's pretty much it. And so then, oops, I didn't copy it at all. Let's see, so we want to copy this. So this is always going to return, oh wow. Perfect, so this is always going to return the entire row from the grid. And then we want to do here grid shape 0. Oh, damn it. Sometimes shortcuts are a bit annoying. And then here, no, I don't want to find. I want to keep those 2. Grid shape 1. And we need the coordinates. Yes, row is an integer and column is an integer. And what I need here to do is I need to remove this, and that I will be specifying. No, sorry, this I don't remove. Yeah, this is still one. Yes, exactly. So we want this one, and then we want the same, but for the column. So that will be get columns, get column, and that's going to be the same inputs. But what is flipped is this one here. Instead, we get the rows, and here we get the column. Perfect. So if we run this and come down here, what I'm gonna do first is, okay, I can just replace this with get oh we also want to update it. That's gonna be a bit annoying. Get row, and then I hate this, but let's do it this way for now. Update row. If you copy paste things, you should probably but I can update it, I think, as a side effect, which is mean, but so side effect is that I will update the object I'm getting, and I'm not gonna increment, right, so okay, let me rephrase. So basically, what's gonna happen here is that I don't need to return anything, because I'm gonna update this object directly, and that is the numpy array. So it's gonna affect it immediately without me having to return anything. But it's good to document that this function has side effects, and that's what we call side effect, that it affects items. It updates the grid and np array object without returning a new object. I'm not gonna add descriptions for now, because maybe we're gonna remove everything later. Let's do the same for, yeah, I'm gonna just do the same for the column. So let's paste this 2 times here. So then that's gonna be increment column. So basically, in programming, if you find yourself copy pasting things, you should rather make extract them out into some layer of abstraction, some basically other combine them into a function, or like a higher level object or a class or something. I'm not gonna do this now, but you can totally see that I copy. These are identical with like only one flip change. And maybe I'm like being too picky here. Of course, maybe that's completely an unnecessary update or like implementation to extract this further. But I do feel like this is a little bit of an annoying copy pasting. But at least we will be able to replace things now. So first, yeah. So let's retrace. So why did we do this? We did this because first we need to know what the values in this array are. No, okay, so the problem is I'm just thinking a lot of things right now. But the problem we had is that we've been incrementing the zeros as well, while the zeros have to be stationary. Actually, I realize now that maybe I don't need to do the get at all. I can just test in here instead if any of these values are zero. Oh, this becomes a bit complicated now. Damn it. I wish there is probably an elegant way to solve this problem. I'm not gonna. I have some friends that are doing this every morning. Going into. I used to do it for a little bit in the beginning, but it becomes quite a lot. Let's see. Yeah, yeah, oh my god. The golden star means that um, they solved the problem, and the ranking is how fast they solved it compared to every other user in this leaderboard. And in this leaderboard, I'm actually not too bad, 12, but I kind of gave up on the ninth day, eighth. What is it? I didn't. Yeah, it became quite a lot to do, and there's like a lot of people that just didn't do anything at all. So, and then we have another one as well. So it's this bunch of friends that are actually doing this every day. Oh my god, it's well, I'm impressed. So let's see. Let's back here. So yeah, so we could. My point was that we could check their answers, but we're not going to do that. Probably some of them are going to be pretty elegant. Some of them are really good coders. I would probably say all of them. I guess probably better than me. So let's see here. So now what we need to do is when we do this update here, we have to avoid updating the zeros. So if something is already is 0, we should not make it. We should not increment it. And how should I go about doing that? What we could do is, yeah, okay. What we can do is we can loop through everything through the row for r in range. Yeah, so the row is stationary. So we only need to loop through columns. So what I'm gonna do is let's see. Yeah, okay, so what I'm gonna do is I'm gonna make this I'm gonna take this out for column in can I make a sequence out of this somehow? Let's see. I think with NumPy I can make a sequence. But can I make a sequence like this? No, of course. I'm trying to see. I can do. Is there like, or maybe there is a sequence? No. No. Okay. Lin space. I know there's a linear space. Return every evenly spaced numbers. No. But this is range. Range is the one I'm looking for. Actually, and then we want to start from this value, and we want to end at this value and increment by. I don't need to say that actually. So this should be enough. Let's see. Where were we? So I'm probably gonna be deleting those actually. We didn't really need them. So if I paste this in here, it should be now iterating through every like these columns and checking. So now what we want to do is let's see. Yeah, so this one should be just this actually, and let's get the octopus energy. And that's what basically we get out. And if octopus energy is equal to 0, we want to skip it, continue. So go to the next octopus. Else we want to actually make it +1. Oof. Like this. +1. Yes. And then we want to do the same thing, but for yeah, I just yeah, I made this like this so that it just looks better. I'm also like I'm still thinking, okay, OCD here, like can I make this a bit nicer? Okay, stop thinking about this left. Don't need to do it. Okay, so this should work, and then we're gonna do exactly the same for, or almost the same for this one. It's just going to be, I'm looking up, actually I should probably write it again. R for row in range. This is going to be this range, and this is going to be, oh wait, I did this the other way around. Or did I copy paste the same thing twice? Yeah, I probably didn't change the code here. All right. Oof. Yeah, I did not. So let's take this. Yeah. So let's put this here. Grid, and then we bring this back nicely here. Up. Oh wait, get me back. Where were we? Here, perfect. So we want to put this in here, and we want to take this out. Make this row R for row, and in the range we want to, oh, I want to remove this one. In the range we wish to do this. Perfect. So now we take whatever range between these numbers is, and yeah, exactly. So we want to know octopus energy from this one first. Where does it take me all the time here? Oh, damn it. Why is it moving my screen so much? And if the octopus energy is equal to 0, then we don't want to do anything. Otherwise, else, then we wish to actually increment it by 1. Wow, that's it's taking a while. Up. Come on, we can do this. Perfect. So there is one thing, I think, one issue right now. Let's see. Grid columns, grid rows. Yeah, so the issue is these don't exist, so I have to replace them. Did I replace them up here? I did. Okay, good. Good work. So let's make this grid shape 0 for rows. Sorry, I had too much for dinner, and I'm a bit food comatose here. And then we want grid shape. No, sorry, what's this? Grid dot shape 1 for the column. And yeah, and this needs to become plus 1 or whatever it is. And theoretically, if I replace these here now, it should work. So we want to increment the column here. So we are going to give it a grid. The grid is our live grid. Why is it not auto-completing? That's strange. I'm not getting any suggestions. Or maybe they're behind this here. So I want the row to be the actual row -1. And I want the column to be the column, because from that number it will automatically create the range that we need. And it will only increment the live grid if it needs to. Otherwise it won't. Wow, okay, we're getting there. And then the same for this one, but +1. Perfect. Wow. Okay, this is starting to become a bit better. And then we want increment row for the live grid, and then we want to do the row Thinking now. Okay, how am I doing this? The row is stationary here, right? So the row is fine, yeah. But we want the column to be no, sorry. The row is no, the column is -1. Yeah, okay, good. Perfect. Just making sure we don't make any mistakes. So this, the naming is a bit off. Sorry. Because the increment row will actually increment. Yeah, correct. It will increment values in a row, and the column will increment values on a column. Yeah, the column is stationary. Oh, that's always tricky to understand the logic. Okay, great. And then we want to do the same, but with +1. Oof. Okay, let's run this. Let's do this. It's been 2.5 hours. Let's do. Oh no, shit. Let's do this. Okay, let's see. Let's hope it worked. I'm not sure if that was updated. So let's go back like this. Let's do this. Okay, 5, 4, 8. Good. Oh no, it's still wrong. But at least there is zeros. Okay. Wait, 9. Because okay, see the mistake here now. So what happened here now is that this 9. Okay, so do they? Well, no, but they are allowed to become 9. So these did not get incremented correctly, and these neither did these. Oh, what am I missing? I'm missing some logic step here. Oh. Oh, my brain doesn't work. Okay, so it has to do with some special condition here. So I'm trying to think of this situation here. So when we are surrounded by 9s and they all become 1s, so what happens? So this makes all these +1. So this one will become 2. All of them will become 2. This one will become 2. When this becomes like this, then this is 0 now. So these all. So this becomes. Oh, all right. All right. I see. I see what is happening. Oh. It becomes 0. So it becomes 9. No, but it should. Wait, that should not be a problem. Wait. So it will be 9. So then this will go there. As long as it's not 0, it will go there and we'll give it a plus point. Oh, wow. This is a hard puzzle. Damn it. No, but that's not a problem. So these in the same round, if it's over 9, it will explode. If it hasn't, so these will all get incremented. Okay, let's. I'll do this a bit more crazy. I'll print every iteration. Yeah. Okay, and we don't need too many steps. We'll only do 3, let's say. And let's open the editor. Let's make sure it's a new version. Come on. Okay, so this is the first step. This is the second step. Nothing changes. And then this is the first increment of the second step. So it passed through everything once and it updated everything. So let's see here. Initially, all these. Oh, no, but there's nothing that is over 9 now. So that's working. Okay, wait. I'm trying to. I'm trying to fix the logic in my head. Oh, okay. We have. Wait, right. So I think what is happening here is that it's something with iteration. So we are going through everything. So then we're going like this. So this becomes 10. Everything has become +1 in this case. So this has become 10. Few things have become 10. So we start going like this, scanning it from left to right, top to bottom. So these don't change, 7 and 6. And then this becomes, okay, let's see here, 9. So it has become, wait. Wait, does it even do anything? It's just adding 1 at each turn. It never really... It feels like it never really goes in here. Maybe the side effect doesn't work. Yeah, I think that the side effect doesn't work. It does not work. Yeah, maybe that's the problem. Okay, let's not do it with side effects. Let's... At this point, I'm not sure if that's the problem, but I just want to make it clear. So I'm just going to return a copy of the grid object. And I'm going to do the same here. And what I'm going to do is I'm going to update the grid here. So let's try again. Oof. Oh, shit. Wait. Yeah, I do something here, right? No. No, wait, what's complaining about? Non-object is not subscriptable. Did it not give me what happened here? Did it at some iteration give an empty it returned an empty grid or like a no grid at all? How did that happen? I'm starting to realize that I probably have just bad debugging tools in when using Jupyter notebooks. We rely on printing everything. Right. We're clocking in 2.5 hours. Right. But it feels like we're so close, yet we're always so far. Let's see. Does the grid not copy does not return anything? But it returns, yeah, an array interpretation of A. All right. That's that is a bit strange here. That should not happen. That should be fine. But what happens is that it went in here, and something of those destroyed the grid. Let's check. Am I previous grid state? Oh, wait. That never works, actually. That is... wow. Yeah, because that overwrites itself all the time. Or like, yeah, it was a reference object, not a A pointer. I always get these ideas wrong. It's a pointer object rather than a reference object. So yeah, so these this refers to the live grid. So if this will copy the state of the yeah, it's a pointer. It will copy before I use that. So now it's a reference. Now we are making new space in memory where we copy over this. So if I move this out again, we should see something. No. What? What happened here? Let's do copy here as well. Non-object is not subscriptable. Blah, blah, blah. I guess I can. What is? But it starts well. It starts with the correct version. It's a copy of that. It goes through one iteration, gets added some values, gets some through the second iteration, and then it breaks here. Can I just print the type of live grid? Non-type. Okay, so something. Let's take this one as well. Oh, it doesn't even. Oh yeah. Okay, so let's see. I think I suspect that if I print this here, it will be yes. Okay, so one of these functions destroys our grid somewhere. So let's see what are we using it at? Do we? I don't see it. Is it a grid limits maybe? No. No, and that even takes what? Grid. That is a very strange error. Let's print the grid just as it is. That is very strange. Okay. Maybe I never run it. It's getting late. My brain is functioning less and less as time flies. So I never run this. So basically, never updated the functions after I added the copy method. So we don't need this or this. Okay, we're getting somewhere. Please tell me we're getting somewhere. No, that's still wrong. Damn it. It only runs once, I think, still. So let's do this. No, it did run twice here. Okay. 2 times. Okay. Damn it. Show me this. Okay. what are we doing here again? First step obviously is correct because we just add one. Second step is it's again the same problem. It did run twice over it though, but there's nothing. I mean, there's obviously nothing to increment anymore. Damn it. So the problem is we're iterating through it like this. So after this step here, so this becomes plus 1, 7, 6, 10, which means that this has to explode and update the rest. So this will become 9. This will become so this works. So now this is the state of this here. So is the problem Maybe, maybe the problem is when I make them a 0. Maybe they should be made 0. No, but then we don't know which ones we've counted. How did it work up here? So this becomes 9. Yeah, this becomes 10, boom, explodes, 10, boom, explodes, 10, boom, explodes. So, but how did that become 3? Since, oh no, then, or no. Oh, okay, I've probably missed something stated here. First, the energy level of each octopus increases by 1. We did that. Then any octopus with an energy level greater than 9 flashes. This increases the energy level of all adjacent octopuses by 1, including octopuses that are diagonally adjacent. If this causes an octopus to have an energy level greater than 9, it also flashes. This process continues as long as new octopuses keep having their energy level increased beyond 9. An octopus can only flash at most once per step. I think we're doing it right. I don't get what's going on here. An octopus that flashed during this step has its energy level set to 0, as it used all of its energy to flash. Adjacent flashes can cause an octopus to flash on a step, even if it begins that step with very little energy. Yes. So my question here is, how did this become 3? And why didn't I spend more time in the beginning, like paying attention to this? Because this explodes once, and it increments all these, but then no one has this as a neighbor again. So this should only be... No, it's correct. Yes, it is correct. Yeah, sorry. So this actually is, everything becomes +1, right? Yeah. So +1 and plus the explosion, 3. Okay, that's correct. Okay, we're okay. That's we're on a reasonable level here. Boo-doo-doo-doo. So what is the problem? Like, why did this? So let's do this mental gymnastics here. So this becomes, everything becomes +1. So this becomes 10. This becomes 9. Right? So actually, okay, there's an easier way to do this. We can just print the grid here instead. So we see how it looks with the +1s, just for now. Oof. Yeah, perfect. So this, let's make it like this again. So this will become 0. And in the process, it'll make that one 10. Okay. So that didn't work. Actually, didn't work at all. Yeah, because as this explodes, as it explodes, it should make this 10. Which means that as we keep scanning, this will become, this will also explode. So this will be 0. Oh, okay, so it's something not working actually. So we make ourselves 0. And we increment our neighbors. Something we're not incrementing correctly. So what we do here, if yeah, so if our row is, oh, no, no, what have I done? This will never run. Um, if it's greater or equal to 0, do this. Um, it will never be, yeah, so it will, because of the way we loop through everything, it will never be able to go over how many rows we have, so that's fine. Um, if this goes, yeah, if this is below or equal to that, to the to our grid, then run here. Oh wow. But how did it break though? Did it go in anything at all? What did it go in? So let's okay, that's something else that's also not working. Let's keep one thing. Let's tackle one thing at a time. So let's hope that now we got something going on. Yes, okay, now, oof, that was too extreme of an explosion here. Everything became 0 now. Oh my god. Um, oof, at least it exploded. So that's good. Uh, okay, there is some good things happening here. I see these where these look the same here as in the example, kind of. So that means, okay, not this one though. That's strange. Oh yeah. So we exploded a little bit too much here. uh, how did that happen? So we're clearly not getting any errors here. So what happened is this. Yeah, maybe it makes sense. Okay, let's do this now. Let's limit the looping to here. Remove this. 3 steps, yes, or 2 steps, I guess. And let's do the printing in actually in each change, in each update. Yeah, if there was an update only, yeah. Perfect. So let's see how this will go. Oof, debugging hard mode. Let's do this. So we start off with this +1. Wait, yeah, right, sorry, no, yeah, never mind. We can skip this one. It doesn't matter. Maybe it's then also nice to print the final one, I guess. Maybe 2 times Desmond. So we have it here as well. Just to make things a little bit easier to look at. So at this point, we need all the help we can have. So yeah, so first this +1 becomes this, and then we get to the incremental updates. So now this looks correct. So it did. Okay, wait, what? This incremented this one twice. So it went. Oh, no, that's. That is correct. How did this. Okay, wait, I need more. I need more printing here. Let's also print how it looks after we give it +1. Yes, and let's go back in. So now we will see every step. So then it starts +1, it becomes this. But nothing changes actually, so that's fine. We're here. Oh yeah, maybe I didn't even actually need to do this. Yeah, so we're here, and this. Okay, so we go in here, and it becomes 9 becomes an explosion. This becomes 9. Yes, perfect. So then when we run through everything again, this becomes, wait a moment. Yeah, okay, yeah, that is correct. This should become, oh yeah, but this we expect to explode. Yeah, right. Sorry. So it's the other corner ones. So this explodes and it makes everything here. I think there's a mistake in the example, or so in this step, in the next step. Oh wait, how many times do I add +1? No, this is only the steps here. Wait, can I be overlap? No. Wait a moment. Oh, a lot of things are going through my head now. This becomes 10, explodes. This becomes 10, explodes. So first this explodes, this becomes 7. And this 10, this 7, this 8, this 5, 6, sorry. So we see this here. Why did this one go from 6 to 8 though? Got added twice. Okay, so I am doing. Oh, yes. I see what is happening. I suspect that I'm incrementing the corners 2 times. I am, yeah. I overcomplicated this thing, but I shouldn't have. Yeah, so actually, what? Hmm. So the okay, I know what's happening here. So we're we're incrementing things multiple times. So we need to change one of these two because they overlap at least at the corners for now. Um, so this one will increment a row. Um, yeah, okay. So this over engineering kind of messed everything up. Uh, we probably were much better off by just manually going through all of the how many 8 pieces of the corners if they exist, or not corner but the grid around. Okay, that maybe wasn't necessary here. Should I just redo this? It's been 3 hours. uh Oh, but I don't want to do it manually. That's very annoying. But that will solve, hopefully, the problem. I also don't want to just change this now because maybe it will introduce more problems, or because we're taking this range. But okay, let's drop these for now. Um, yeah, let's drop these for now. Let's do it manually. Let's live grid. So we want the row that is above us, if it exists, to at the current column to be incremented. We want so let's increment. Yeah, let's increment all the above ones, all 3 of them. Then do the same for the ones below, and then do left and right here. Yeah, let's do it like this. Crude, but you know, if it works. So we want plus 1 if that's possible. So we have to make a condition for that, -1. Because it could be that one of these doesn't exist. So let's say if call +1 is less or equal to grid columns, then do this. This should always, let's think, yeah, because the +1 is the problem. The other one should always exist. Yeah. And this should be the problem, the thing here as well. So here we're doing below, so it's so it's instead of +1 we want instead of minus, we want to have it plus, because we're doing the row below. And then we want to do the same here as well. We want to do +1, the same, and -1. And then we also want to perform this check here to make sure that this column is not out of our allowance. Do I have to? Yeah, I have to. -1. Perfect. And then here we want to just do the left one as long as it exists. We want the current row, but -1. Yeah, that should be like this, and then +1. So this should actually work. So let's do this. No, what happened? Index 10 is out of bounds. Okay, so I messed something up. Oh yeah, I did. I did not do -1 on that one, so it's this one here. Perfect. It looks like it worked. Let's see. Do we win this one, or did we lose? Let's see. Let's try it again. I increment +1. Then we have this first row. Yeah, it start. Oh yes. Oh, it looks good. It looks good. It looks very good. Okay, let's go directly to the results. Let's skip printing this what is it? I don't know. The one in the middle. Okay. Oh, please tell me it's the correct one. No, it's not. Yeah, okay. Yeah, I know what happened now. So that, yeah, yes, okay, we're almost there. So what happened is that we should not be incrementing the zeros. Oh, so this is going to be annoying now. So we will have to be testing. Oh, wow, that's going to be very ugly. So at least I want to solve this before it becomes too late. Now it's 10 p.m. And maybe I should have solved this the stupid way first and then try to refactor it. So that's lessons learned here. So let's do it the stupid way. So we want to just check that any of these are not 0 before we actually perform anything on them. Ugh, wow, how many if statements am I going to write for this one? I don't want to know. I don't even want to think about this. If it's not 0, do this. Oh my god, this is gonna be horrible. Okay. Can I do? How do I do this? Perfect. Yeah. If this is not 0, then do this, and wow, this is really ugly. Or actually, I can do again this. No, sorry. This. If, oh my god, we got this. Then do this. Blech. This is absolutely hideous. Um, but I wouldn't have spent the better part of this hour implementing, debugging my bad solution. So, lessons learned. Um, Again, the same thing. Bam, bam, bam. And we want, oop, wrong one. If this is not 0, do this. If this is not 0, then increment it. If this is not 0, increment it. And here we are, some more nasty code. And let's do the same here. If 0 and again if okay, so now it should work. Let's see. Let's highlight these ones. Oh, I was so ambitious. I was gonna be like, oh, let's paint them as well. So yeah, it looks correct. No. No, there is what happened here. There is a 7 here. What? No. What? How did that happen? Oh shit! But nothing exploded here. How did it go from? So how did that become 6 here? And here's 5. No. The zeros look correct. So something went a bit too far. Like, it's just 1 digit. How did 1 digit get wrong? No. How can it be 1 digit? They look, otherwise okay, no, there is one more wrong here. This is like, at this point, this is like, where's Waldo? Oh, they got incremented 2 times instead of 1. No, how did that happen? Okay, maybe this is something. Let's see, is there a pattern to this? Something exploded in their neighborhood that could have touched them accidentally. Is there just breaking my brain with some random social media posts here. Okay, LinkedIn is becoming a little bit more interesting these days. Some people post something nice or interesting sometimes. No, nothing much going on. Okay. How the hell did this happen? We have this freaking. Everything looks. I can't see anything. Okay. No, that's correct as well here. Okay, maybe there is something more. Maybe that is wrong, but okay, let's try to figure out how these can explode wrong. So they were a 2 and 5 before, and they should have only been incremented once. So what happened here that made them increment twice? Could it be is it because of this one? Because it may be wrapped around. Yeah, it feels like it. So, okay. Can I have it right here? So it wrapped around. Let's see. So here we do the corners as well. Now I'm not thinking about anything. Okay, the corners. It's the corners are these actually. So it's this. Mm, oof. Um, it's it's this one here maybe, or yeah, it's this one. It it is this one. Um, okay, got it, got it. Um, yeah, we can. So yeah, I can merge these conditions in one line with an end statement, of course. Now I'm just thinking about how things look like. But I think it's maybe okay to leave them like this because it looks a little bit more legible. But that's just my opinion. Um, so I only want to go in here if the column -1 is not negative. Basically, that's what happened. Okay, we got this. We got this. Virtual high five. Bam. Out of bam. Oh wow. Okay, that was a sneaky one. Um. All right. Get away. Oof. That's a lot of loops here. Oh yeah. Wow. That is. So we would again here. We want -1 to be positive. Damn it. There's so many traps. But now this is, yeah, so if I had written this like this from the very beginning instead of trying to be smart about it, we would have finished way earlier. So this doesn't, that's a bit sad that it doesn't work like this anymore. Oh, please, 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 please. Okay. Let's see. So what was it? It was these, yeah, they look correct now, right? Yeah, okay. Oh, wow. 3 hours too many. Bam, we got this. Okay, so now we actually need to implement the way to solve the puzzle. They get the answer to, oh no, to get the answer to the puzzle, which is we need to wow, yeah, my brain just stopped now. We need to count, yeah, given the okay, after 100 steps there's, okay, we need to count every time there's a flash, so that's pretty simple. Okay, so we just need to we can stop printing here for now. So the only thing we need to do is every time there's a flash, we need the flash counter. So let's create a flashes counter here, which is 0, and increment it every time there's a flash, pretty much. Octopus flashed, flashes becomes +1. And in the end, print I don't know how to write this. Flashes octopuses flashed times. Okay. Oh, it printed still. Oh, it printed this. Wait, what did I do? Ah, okay. I'm printing this in every step. Sorry, I want to print it only at the end. Perfect. And then I also want to take this one away for now. Okay, let's do this. 10 steps. 10 steps. Actually, what I'm gonna do is I'm also gonna make this look a little bit nicer, like 20. Well, not 20, right? That's not gonna be so large, but maybe 6 digits. I don't know. And then we can actually have it in every iteration. And yes, maybe 5 digits is fine. 204 times. Okay, let's double check the numbers now. So in the example, oh no, that is very after hundreds. Oh, I only ran 10 steps. Sorry. Yeah. Okay. 204 flashes. What do we get? Yes. Okay. Perfect. So now actually I should not print this in everything. Let's do the 100 run. Let's blaze this. Okay, I think that's correct. Um, yes, bam, nice. Okay, so now finally it's time to use our own inputs. So let's remove this from here. Let's save this notebook, restart everything. Oh wow, and run everything. Oh, okay, so this should be the answer to my puzzle. Let's see. Haha, yes, nice. High five. Damn, nice. Oh my god, wow. That took 3 hours too many. Okay, I mean, I'm not saying that I could have solved it in 12 minutes, but if I didn't get stuck with all this trying to like preemptively, like prematurely refactor things here, it would not be taking as much time. It looks ugly, but it works. And that we can improve later. Okay, so now we have part 2. Let's see. Okay, I have some energy now. I'm gonna go get some water. Be right back. Okay, here we are. All right, so ready for. Let's see if the part 2 is too extreme. Sometimes, depending on how you solve part 1, part 2 is pretty easy to solve, but sometimes it's not. Right, let's see. It seems like the individual flashes aren't bright enough to navigate. However, you might have a better option. The flashes seem to be synchronizing. In the example above, the first time all octopuses flash simultaneously is step 9 at 195. Okay, I'm starting to see where this is gonna go. Ah, okay, maybe it's not so complicated. If you can calculate the exact moments where the octopuses will all flash simultaneously, you should be able to navigate through the cavern. What is the first step during which all octopuses flash? Okay, I only need to find the first time in my things that if they all flash together. So in the example, it is 195. So if we roll back here to the example input and run everything. Perfect. Then we will get yes. So now what we need to do is okay, that's pretty simple actually. Okay, so the only thing I need to add is a step counter. I don't even need to add that actually. We already have it. So I have a step, so we can print which step we're in, and then I just need to in here I can add another condition that is if so if the sum of all the values in the NumPy array is 0, then we got it. So that's actually that's surprisingly simple. So Python is a little bit of a cheat language to use in advent of code. A lot of times there's libraries, especially like NumPy, that really make things smooth, to like easy to. I don't have to implement like a function to just summarize all the rows of the and columns of my array. I just can do it like this. So if I do live grid dot sum, I think I have to add another sum just to make. Let's test it here. Live grid dot sum is probably gonna sum in 1. No, okay, it's a total sum. Perfect. That's perfect actually. So then if that is equals to 0, then print out step step and do this maybe, I don't know, like 5 digits in, or like in step, I don't even need to make this in step the number of the step, all octopuses will flash simultaneously. Oof. Okay. Let's do this. Oh no, it never occurred. Really? Yeah, because yeah. Oof. Okay, so I'll just have to randomly like put a okay. So let's put this to 200 here. Yeah, I know what happened. Like it doesn't happen. Oh, it happens. Wait. Why is it printing this 2 times? Yeah, okay. Yeah, sorry. It's in the I have to bring it out here. 1 level out. Perfect. We only need this. Yeah, that should work. We only need this in the outer loop, in the steps loop once. So we don't need to test about it for this every time. Yes, and then we, okay. So that, what is 194. Okay, so, and that is correct. Okay, that's good that I tested with the example first, because, yeah, we do need to do like this, because the step is, starts from 0. So it's 195, that's correct. And if we change to our own input again, restart everything just to make sure and run everything, it did not happen in the first 200 steps. So that's a little bit of a like testing it out. So you know, just trial and error. Okay. Oh, okay. So we got a few. So the first time is 354. Wow, that's funny. I wonder how often it will happen. It seems like they are all pretty every 10 steps. Oh, is it stuck in a loop after that? Oh, let's find out. Yeah. Okay. So why I want to plot this like in a nice animation is because we will be able to see that like there is interaction, like all these things. Uh, oh wow, this is not even cellular automata. Oh, or I mean, it kinda is, but it is, but it's also like a simulation of a dynamical system right now. So I guess cellular automata is a dynamical system. So uh, this specific system from the initial state we got in the puzzle will okay before I keep saying that, it will basically it will or no it's not no there is another way for it wait another name for it let's put this in first I'm getting a lot of things in my head now bam nice now we got 17 golden stars let's see how we get promoted. I don't even remember how it looked like before. Uh, did we jump over some maybe anonymous user? I don't know. Um, oh, that was such a nice one. I was really looking forward to solving it. I'm really sad I started off a little bit wrong, too complicated. I think that was a lessons learned for me now. So yeah, so what I wanted to show is that what is this called? Um, it's not it reaches like an equilibrium. Oh wow, but too many things in my head. This is cellular automata because they do have like a simple rules in how they interact with each other in a grid. Um, but the reason they reach equilibrium is it like steady state or is it called like this? I don't remember. Wow, that's yeah, state. Yeah, that's university stuff. In theory of systems and process steady states, Werner, which define the behavior of the system or process are unchanging in time. In continuous time, this means that for those properties of P of the system, the partial derivative of the respect to time is zero and remains so. No, that is not steady. Yeah, dynamic equilibrium, maybe. There are some really nice. No, it's not like this. Wow, I think I almost had it. It like I had a memory of my dynamical systems chaos theory class in school. It came back for a brief moment, and then too many things came to my head, and I can't remember now. But we solved it. So hey, bam, high five. So what I still want to do is I want to make an animation. That would be really cool. So let's see, can we make animations with Plotly easy or do we? Can I do with Plotly Express? So Plotly is also a pretty cool library, Python library. They actually have a bunch of others. A bunch of other languages they support. Let's see. Oh yeah, yeah. Okay, so you can do like this. Ah, that's a cute animation. But that's but we can have it in. Oh yeah, nice. We can have it in Plotly. I like you to use the Express version of the library, so I don't need to care about too much. Animation frame is year. I wonder though if I can have an animation frame in three, an entire array or matrix. Yeah. Okay, let's see. Current animation limitations caveats. Animations are designed to work well within each row of input. When each row of input is present across all animation frames, and when categorical values mapped to symbol, color, facet are constant across frames. Animations may be misleading or inconsistent if these concern. Yeah. Although politely express supports animation for many chart and map types, smooth interframe transitions are today only possible for scatter and bar. I don't care. Will not automatically compute the union of all ranges. So these must be specified manually to avoid scale jumps across frames. Okay, yeah, that doesn't matter. Along with data and layout, frames can be added as a key in. Okay, see, I don't think. I think the problem right now is that this is not. Let me figures plot express. Yeah, that was in here. I think the problem we're going to run into is that it probably expects a two-dimensional array. It probably does not, or yeah. Let's see. Maybe. Let's change our search term. Plotly image animation. Maybe I shouldn't do it with Plotly actually. Let's do matplotlib. Matplotlib is like a pretty standard Python plotting library as well. I think it's very familiar for people with MATLAB or R, or maybe not R, but MATLAB. Yeah, plotting tools. We want imshow animation. Imshow is one like module. Yeah, okay, let's see. Stack Overflow, why not? I found this wonderful short tutorial on animation. Oh, nice. Basic animation. Okay, so what was his problem with this tutorial? However, I can produce the animation. I can't produce it. Okay, so he tried something that didn't work. Maybe I can just look at the source then and see if I can avoid this mistake. So, we get the plot. And there is animation is a module of plot matplotlib. Okay, cool. Oh, I never seen this like this before. That's pretty nice. Right. So what we do, we create a figure, set the axis limits, and create a, what is this line here? I don't know. Okay. They're making a line. Okay. Initialize this as an empty set, and then line set data. Okay. So this is like how this animation function works. It takes in a figure. It wants a function that is possible to animate. The initializing of this function, and then you just create in a video animation. Okay. Can I have it in? I don't really want to make a video of it, but let's see what was his problem. So he did that with. He didn't import anything. I wonder if that's just assumed, but I run into errors. What errors? Like, are you importing anything? You're very close, but there's one mistake. Init animate should return iterables containing the artists that are being animated. That's also pretty, like, I never understood, but the concept of artists in matplotlib, I haven't really looked into it much. That's why in Jake's version they return line, which is actually the tuple rather than line. Oh yeah, wow, that's so sneaky. Oh wow. That's so sneaky. So he creates a tuple with this comma basically. So this returns line and nothing. So it's two. Is a tuple is. What's the difference between a tuple and an array actually? Or not array, but list in Python. I don't remember. I don't know. Let's take this. Six most valuable differences to learn. Oh, I hate this. Like catch. Like what is this? Free code camp. Wow. What are these all these blogs? I just want like a. straightforward. I don't want to read an entire blog. I want to use each. Stack Overflow maybe. Hopefully, tuples are fixed size in nature, whereas lists. Okay. So tuples cannot be append. You cannot append things to tuples. They are created the size they are. Lists can keep increasing in size. So tuple is immutable, where list is mutable. You can't add elements to tuple. Tuples have no append or extend. Yeah, okay. That's basically what you can't remove. Yeah, okay. You can't find elements in tuples since it doesn't. Oh, you can find. Okay. I thought it said you can't. I was like, that doesn't make much sense. You can also use the in operator to check if an element exists. Okay, that's fine. Tuples are faster than lists. Okay, that's pretty cool. Okay, good to know. So if we go back here, down. Let's see. So his problem was that he was not returning with a comma from here. That's easy to miss, of course, especially because they could have made it a little bit more obvious here and make a parenthesis, so that is more obvious, but sure, okay. So he made it a list. It's not iterable. Okay, yeah. So it doesn't matter. Yeah, okay. As long as it's not. Yeah, as long as it's a list or like iterable, so that you can run like iterate through. That's why he does it like this. It's a bit ugly. Contain the artist and be animated. That's why Jake, yeah, line, which is actually tuple rather than line. Yeah, okay. Okay, so it should work. So maybe I can just copy this as it is. Classic. And go. So one thing I need to do is store every frame of the animation. So let's make this frames and make it an array. And actually, yeah, so can I make... So since I know, yeah, I could make them tuples to save space or in the memory, but it doesn't really matter. Can I make the live grid into a list? Nope. No. To list, yes. Okay. Nice. Perfect. So then, perfect. Then I can do this in here. So we have our first frame already. And then at the end of each step, I will be, let's see, here, yeah. At the end of each step, I will be frames appending, append live grid to list. So now we will create a frame for each, yeah, perfect. So for each time, we get a frame for each step, so we see how the values evolve over time. So if we run this, we have all the frames here. Oof, that's pretty heavy, yeah. Yeah, so if I take like frame, let's say 100, I should be able to see how everything looks like at that point. So if we do import now the import matplot or from matplotlib pyplot import as okay. I can do it as import. Yeah, I usually do it like this with the dot. I find it a little bit more transparent as plot. So I usually just do this. So I just rename this thing into PLT, so it's easier to access as well. So if we it took a while to load as well. So if we do plot im show is just show this as an image. Perfect. Yeah. Oh wow. Oh, it's gonna look so great. Oh, I love it. So we can remove the axes, false, and we can remove the. No, okay, axis maybe. Yeah. Oh, oh my God, it's gonna look so great, even with just like the standard colors. So 0 is the darkest one, and these are probably 9. Maybe I can do plot color bar. Yeah, exactly. Oh, wow. Oh, this is gonna be so great. Okay, so now we need to steal the code from these folks. Oh, I did not steal the code. Let's do that. Perfect. So this, what is he importing as IM actually? Set data. Um, line. What is line? Oh, okay. First, set up the figure, the axis, and the plot element we want to animate. So for us, not going to be. Okay, yeah. So let's copy it as this. I'll keep the credits also. Always do that. Always keep the credits in. So let's keep this instead. So thank you, friend. And so I don't need to import this anymore. I already have it, and I already have this too. So basically what I could do is just, so I like to always have the imports at the top of my file. So let's take this as well, and let's put everything up here. And this one, perfect. So if we come here, yeah, nice, very welcome. Perfect. So we create a figure. We set the axis limits. We actually don't need to do that because our array is always like this the correct dimensions. So we actually can set the axis. Do we need? Okay. Okay. We can set it from 0 to grid rows. No, sorry, columns. Or let's do it like this. Grid shape. 1 as a width, and then we do this. We want to go from 0 to the n number of, so that's 0. But we want it to be -1, yeah. Or, yeah, I think it should be -1 because that's going to be 10, so that's going to be like 11 pixels, but our image is 10 pixels. So we have the axes set up, we have the plot, but then it's not going to be a line, so I want to replace that with a okay. Yeah, okay. I think I understand what's going on here. And also, if I look at this other person's problem, they initialize an image like this. Yeah, okay. And I don't want to interpolate frames either too. Yeah, okay. So he just named this IM for image, and he just like puts in some random stuff. But we can put our first frame in actually. So that's perfect. So AX. No, I don't need to do that. Yeah, but where does he uses the axis information? Actually, he doesn't. No, he never uses it. We don't need it. We can drop the axis information. It's fine. So and then we can drop this as well. So let's make this a plot image show and actually put in our first frame, frames 0. And I don't know if we need the interpolation none, but I'm gonna keep it here for just to remember that I want to test how it looks like. I'm not sure if this will return. Yeah, exactly. So I think we just need this as this way. It won't. I don't think it returns more than one thing. Maybe it does. Wait, let me. If I take this away, yeah. So I think it returns both the presentation and the actual object. So maybe let's test this. Image, comma, nothing. No, okay, never mind. Never mind. Okay, I had an idea, but it was not correct. Perfect, never mind. Okay, so we just return one thing. And we want to set the data to... I think initially should be frames 1. Yeah, the first frame. That's fine. And then it can, in every iteration, it can be set, frames I, if that is like the number of the frame. I'm assuming that is what it is. Maybe it says above. This is called sequentially. So basically what I need to figure out is call the animator. BLIT true means only redraw the parts that have changed. That's smart. Yeah. Interval 20 frames 200. What is interval? I wanted to go each step if that is what interval is. Let's figure out. So fig is a fig is a figure object we've initialized, and then we have a function to call. The function to call at each frame, the first argument will be the next value in frames. Any additional positional arguments can be supplied via the f arguments parameter. Okay. The required signature is frame, iterable of artists. Oh, it should return all the, okay. If the BLIT is true, the function must return an iterable of this information is used by the blitting algorithm to determine which parts of the figure have to be updated. Okay. If it's false, okay. Frames, iterable int generator, source of data to pass to function, and each frame of the animation. Each frame of the animation, should I make it is maybe an integer? If an integer, then equivalent. Okay, perfect. Okay, so it will make it like this. So it will basically say, here's the range of frames we want to have. So let's take 500 frames. Even though when did we start repeating at 300? So maybe we can stop. Oh, yeah, but 500 is okay. 500 frames. So this should, yeah. So let's name this. I want to save it somewhere. That is not in the solutions. I wonder if GitHub can play MP4 files. Okay, maybe I can make a folder here, say named media or outputs, maybe okay, maybe not in here, but maybe I can make it here actually. Outputs, and then I can say in outputs, or not like this, and the file type should be let's say an FPS can be maybe 25. Actually, we don't want it to go too fast, so that's going to be 500 divided by 25. That's 20 seconds. That's pretty decent. 25, maybe 25 and it's super much. Uh, yeah, maybe we want even fewer. Let's start with 10 frames per second. So it's 50. So it's almost a minute. So let's name this day 11 octopus dance. I don't know. Oh no, dance flashing. Octopus is flashing. And yeah, let's see. I don't know if this requires the FFmpeg or mencoder to be installed. Okay, let's see if that's gonna work. But I think everything else should be okay. Yeah, let's test it out. Okay. Move. Okay. What is this? Got an unexpected keyword argument. Extra args. Is this? Oh. Okay. Maybe it's an older version of the library. Let's see. File name, writer, DPI, extra. What do you mean unexpected argument? List it's just here. Extra args. Maybe is there something? Maybe in the encoding of the text. What is init? What library? Animation. Movie writers are available. Using Pillow instead. I don't think Pillow is installed. I don't have Pillow, so I think maybe that is the real problem here. Or oh yeah. So let's try to install Pillow maybe. Search Pillow. So Poetry is this Python package manager. Kind of like is pretty nice because it. Okay, I think that's the one we want. Because it kind of takes care of your figuring out your dependencies properly and also building your wheel files and everything. So it's super nice. Let's see if I do install Pillow and I run this again, will we get the same error? Because if it attempts like what a writer is even like it said 79 installs. Oh my god. Oh wow. I have far too many dependencies on this project now. Markup safe, matplotlib inline. Ah well, what could go wrong? It needs. Yeah, let's see. It does need. Yeah, it does need FFmpeg or Pillow. So we'll see. Did they say here any suggestions? This is the animation. How does it look like actually? So this is for 30 frames per second. That's pretty nice. But ours is super, like it's gonna be one frame is a lot of changes. So we don't wanna. Oh, there's more. Wow, that's pretty complicated. Oh, it's double pendulum simulation. These are pretty cool. Yeah, that's like another chaotic system or dynamical system. You cannot predict based on the initial conditions. The double pendulum will always oscillate differently. It will like it follows a certain pattern in the beginning, but then it becomes like its pattern becomes chaotic. It never repeats. Oh wow, it keeps going, but he doesn't say anything about or she. I don't. Sorry, I mean no, I don't mean to. But let's try this again. So now that we have this, make sure Poetry is and everything is installed. Just making sure. Just save, and we need to restart the kernel as well, so we have everything. Run all. Let's see. No, it didn't work. Okay. Then let's just, maybe I should have just tried this from the beginning. Oh, something is happening. Let's see in the monitor, activity monitor. Are we burning my computer yet, or? Oh yeah, wow, 90%. Python is going crazy. Oh no, what happened? Before unknown extension MP4. No, it computed everything, but then it didn't know how to. Oh yeah, and I need to remove. I forgot. Good. I need to remove the access false, and I need to show the color bar. Perfect. I wonder if this is going to. Do I have to do this on the figure? I wonder. Let's try this. Maybe. No, it doesn't have fig. No. Maybe it doesn't know. Maybe right now. So maybe we can just try it either ways. Okay, so this was a bit annoying. So what does he say here? Save the animation and before. This requires FME on Mercoder to be installed. Okay, I think we can just poetry. Oh shit. Let's actually roll back. Remove pillow. Pillow is like a image, like a really good image processing library for Python. Wait, what? Did that remove the dependencies? Nothing to install or update, but I don't want to have pillow anymore. So I think I should just have. Okay, let's just go to documentation and see how we should do this. Okay, animation API, art, blah blah. Okay, no. To save an animation, you save or to HTML. Oh, that's pretty cool. HTML5 video. So convert the animation to an HTML5 video tag. This saves the animation as an inner. There, blah, blah, default FFmpeg. And how can I check if I have FFmpeg actually? Oh shit. I also wanted to make sure that we have removed any unnecessary dependencies. Okay, we're hitting 4 hours soon. That's going to be a blast. Updating, okay. But did it remove the ones that I wonder now? I haven't been using poetry for too long, so I wonder if in this process here, it didn't say anything to update, but I wonder if it uninstalled these libraries from my local, from my environment, from a Python environment. It looks like it, so that's pretty compact now. We don't have that much. Oh no, that was the updates only. Sorry. So if we look at this at the Python no, okay, we only have these here. So I wonder if am I in a shell? Which I am. Okay, so if I do Python module pillow, or yeah, will it work? No module MP. Okay, then it's uninstalled. Actually, it's not pillow. Yeah, it's PIL or PIL, things like that. Shit, it's installed. Yeah. Okay, that's good to know. So it did not uninstall them. Oh, I don't like that. Maybe I shouldn't. Is there like no? There's no way to clean. Interact with Poetry's cache. Neat install lock new publish run. No self shell show update version. Oh, But it removes a package from the project dependencies. But I want to. I don't want to have them at all locally. Can I? That's something to figure out, I guess. I did not know that Poetry did not automatically remove these things. I don't want them in my environment at all. Maybe like this, Poetry N. Okay, Poetry and there we go. Poetry and remove pillow. No, what? Oh, damn it. Command not found. What? Python remove. What does this even mean? Python. Is it like a file? Okay. It removes a specific virtual. Okay. Oh, so what I could do is I can remove this virtual environment and just recreate it. Let's not do it now anyway. Okay. Let's see. Let's go back to this one. So FFmpeg to HTML5 animation. So what are we using here now? Oh, sorry. We're using save animation, func animation. Okay. So func animation is, I don't even see it here. Pillow writer. Oh, maybe that we can use. Grab frame setup. No. Okay. Animation. I don't even see it here. Animation dot func animation. Maybe in here. No methods. File right, but I kind of want to save this to this one. Let's test this one out. So, what does it take? But it has to be initialized as a. Save. No, here it is. Save writer movie writer. What is movie writer? A movie writer instance to use. This is FFmpeg. This base class for movie writer subclasses that write a movie frame data to pipe. You cannot instantiate this class directly. Okay. Frame format. Blah blah. So this is like an internal thing. Damn it. Okay, that becomes a bit extra animation, extra arguments. Okay, do I have FFmpeg? Let's do it. This FFmpeg. Oh, okay. Download, or how can I test? We likely can do this with Brew, probably. So probably can check if I do have it by just running FFmpeg. I don't have it. Okay. If I exit this shell for a moment and try again, peg. No, okay. Brew. Is there like a search function? There is. It seems like it, at least. Or it's taking a while to reply. Is it searching for everything there is? It requires at least one. Oh yeah, good, perfect. So we want what's it called? Brew. FFmpeg. So let's see. There's a few. But I wish I could get a link to them. Verbose. Maybe make the somehow more verbose. Maybe that will be. Maybe it will give us a URL that I could. No. Okay, never mind. I just like to check Brewdog. Yeah. I just like to make sure that what we're installing is going to be. FFmpeg had a lot of issues in the past, so we don't want to install whatever it is. Current versions, okay, stable. Other versions, sure. I want to see the current version on GitHub. Yes. So blah blah blah. What does it do? What was it updated in November? Perfect. So somebody is looking at it. How often does it get updated? Oh, that takes a while. Partially verified. What is that? Commit signature. This commit is signed with the committer's verified signature. We cannot verify signature from co-authors. Okay. So there's like this. Maybe it's. I think it's this bot probably that introduced some let's see. If oh my god, that's a lot of commits. Oh wow. But if I look at these commits in this particular version, no. Okay, so who was the one that doesn't have a verified signature? Is it both? I can reply. Who of the two does not have a verified signature? Can I see? Damn it. Anyway, it's probably not this person, I'm gonna guess. Anyway, it's not such a big deal. I just wanted to check that nothing suspicious is going on. So it checks the download URLs. Okay, it has like some checksums, and we can get the checksum maybe from static builds. Okay, can I signature? I have to download them. Can I just see the signatures here? Maybe no. So somebody had to like manually put them in, but the link looks correct. I mean, it should be there. Depends on a bunch of things. And then, okay, it looks. The URLs at least look okay. It's pretty hard to know if any of these are like some Theodora Tesseract. Why Tesseract? That's also an awesome band, but also a it's like an OC. No, is it OCR? I think it is it is an OCR engine. Yeah, I remember. I've used it before. Why would it need it? Okay, whatever. Anyway, is it like a light version of FmpEg, or do I get all of this together? Fuck it. Let's do it. Why not? That's gonna take a little bit. Pre-install. What's that? Oh well. Okay. This animation has to be fixed soon. I really need to hit the bed. Oh yeah, I should put the link to even though probably everyone knows this. We've been listening to this live stream from our favorite lo-fi girl, and I should put it in the description of the video. So I unfortunately don't know the songs that are playing. So music from the lo-fi girl, a live stream. And I can maybe also tag the channel so people can find it. Can I? No, I don't wanna. I wanna copy the link. Yeah. Okay. And log-fi. I wrote lo-fi girl YouTube channel. Yeah, I really hope that. I guess this music is not really. How it's called? Yeah. Okay, this music is free to use in your live streams and videos. Perfect. Oof. Good that. I mean, well, we're not making any money, obviously, but we're doing for the fun of it. But it's good to know that play the radio, create a channel in live stream. Yeah, I did that. Okay, good. We love Lo-Fi Girl. Oof, this is gonna take a while. I hope not too long to install. I So the problem with FFmpeg is that it's been quite of a messy library overall, with FFmpeg vulnerabilities. So I think it's been, yeah, it's been having not a great time for a long time. It has 316 vulnerabilities over time. So what's the latest one now? Suffers from assertion failure. So what I don't like about FFmpeg is that allow attackers to cause a denial of service. Wow, that's very interesting. Wow. But this is not a big issue. I think it's more of an issue for servers that use FFmpeg. So that's in this case probably some, like, if you do some sort of operation in your, like, or your video that like has, let's see, um, version details. No, or not version details. Sorry, vulnerabilities. These are related to this, I guess, or I don't know how to. I used to know how to navigate this website back in the day. References. There's a ticket. And then they describe the issue here. Yeah, there's 3 saying if okay, sometimes it's easier than that to figure out what kind of problem the vulnerability introduces. This is just some that fixed it. Okay, but anyway, the reason being that, yeah, it's a bit of a sketchy. It's still like pretty standard, very standard library, but it's pretty often vulnerable to certain attacks. So maybe not something to worry about when we're running things locally. But let's see. Okay, well, I really hope this ends soon. So hopefully after this is over, we should be able to just run this and be happy with the video. Another annoying thing is that this is installing all these dependencies that I did not want, but maybe I did, but I don't know. Like, why do I need Tesseract? Now it's not here. Maybe it didn't. Maybe I already. Oh, actually, I have Tesseract already installed, I think. Because I'm using it for this other pretty cool tool, which is Alfred. Alfred is a pretty neat. Yeah, this one here. So basically, Alfred is this like shortcut tool. So what I can do is I can like double press. Okay, you don't see it here, but can I bring it to this screen? Yeah, there you go. So I can. Okay, and it remembers the screen it should be on. Good. So this appears, and then I can run some commands. So for example, I can search through my windows by doing W, and then it's like between tabs, yeah. So you can see all the tabs I have open, and I can search through them, WhatsApp, and then I can do the same with Firefox various things. And then I can also do OCR, take a screenshot and recognize. So that's pretty cool. It's gonna, let's see, let's take a screenshot of something that's easy, like quite clear. Yeah, let's take this here. So I'm gonna take a screenshot of that, and you'll see. Oh, where did it go? No. Oh, I did not recognize it at all. Yeah, okay, that did not work very well. But sometimes it works. I think the problem is that it's a very small letter. So I think I'm using it here. Yes, I am. Exactly. So I had Tesseract already installed. So basically, it receives a screenshot that I took, and it's saved in my temporary folder, and tries to read it. Otherwise, it tries to read a file if I provide a file. No, this is to save it somewhere list, or I don't remember now. Uh, I did not write this myself, I think. Yeah, and then it copies it. So this is like a flow. So once the output of this is going to be like a string, and then it outputs this to a notification. So I get a notification that with the content of what it read. For some reason, it didn't appear now. I don't know why. And then also it gets copied to my clipboard. Just the result of it. Yeah. Oh my God, is it still going? Oh, it's over. Perfect. So, yeah. So I can actually just OCR for no good reason. But if I do it like this, oh, the notification is not showing up. But you see, so this is my clipboard history, which I it's fine for now to have it here, but usually I hide it away because in a stream you can. The good thing is that I get access to everything I copied in the past, but I can have copied passwords. So then it will appear here like bam, here's a password. So that's why I'm gonna move this back to the other screen. But you can see, yeah. So the point was that you can see this is called sequentially, and it copied it. It read it from here and it copied it to my clipboard, which is pretty cool. And then I can. I don't need to copy it again. But I mean, of course, in this case, I can just copy it from here. Anyway, let's go back to using these extra arguments and do this again. It complained. Something broke. It. What is this? I have collapsed the output. Sorry. List is not callable. Okay. Okay, that's a different problem. I'm not sure if this is gonna work though. Okay, oh wow. Mode from bounds argument after must be an integer. Oh my god, this is getting too deep now. Okay, think I see what is happening here. Let's pyplot figure show color bar. I think yeah, I have to. Yeah. How do I? No, what I want to do is I want to tell the figure to not have a. Okay, let's go back. Let's go to pyplot figure here. Figure size, face color, edge color, blah, blah. Keyword arguments. See figure for other possible arguments. Okay, what are the other possible arguments? They're already here. Are these all the ones? Oh no, it's it's another type of figure. Okay. And there is even more. Okay, frame on layout. Okay, there's they're all here. So let's see. Axis is not here. That's not cool. And okay, and the other thing, color bar is not there either. So how do I change the color bar on a? Okay, so if a figure, what does it return? It returns a figure object. What can I do to this figure object? Can I constraint layout? No. Can I actually the artist add axes? Can I remove axes? I don't want any axes at all. Axe add. It clearly doesn't have. Oh, and that's over here. Okay. Can I do? Oh, where am I? Axes. Oh, there's too many axes. Damn it. Of course. Okay, so what I want to do, I don't want to read through the entire documentation now. Let's figure out a way to just do it quickly. Matplotlib figure hide axes. What is this? Yeah, okay. Yeah. Ooh, I kind of remember this one. What was this? Figure get G C. No. Get axis. No. Hide axis with examples. Oh, this is gonna be like a blog, right? Yeah. Oh my god. Oh, okay. Get current axis. Can I just? Oh, maybe I can return. Can I return the axes from? Figure get axes. Ah. Yeah, maybe that's how I should do it. Let's do it. Get axis. And then axis is like this. And then we say axis set. Oh, you got very... it's not recommending anything anymore. Okay, let's go axes. We want to spans, no. We want to hide. Being unstructured. Oh, okay. Yeah, there we go. Appearance. Set axis off. Turn the Y and X axis off. Okay, yes, we want this. Wow, I forgot how complicated Matplotlib can get. And now I'm just trying to remove. Okay, wait. Let's just fuck this. Well, I did swear after all, didn't I? Let's just run with that. Yeah, okay. It looks like it's working. Let's reach the save part when it's gonna crash. No, it didn't. Maybe, but it's not over yet. Oof, wow, it's going for a while. No, I don't want to open, but I want to see it in the Finder. It's a video file, for sure. Okay, well, it looks like it's done. Let's see. Ah, nice. Yes. Wow. It's moving. These are the octopuses, like, doing their thing. Watch. Oh, and now they're gonna start getting symmetrical. Oh, okay. No, they failed. They're coming back. Whoa. Wow, that's nice. They're almost there. Almost there. Oh, wow. Wow. Oh, that's so cool. They're just in sync. Oh, yeah. Okay, so that's it. Wow, nice. Okay. Oh, I love this. Oh, that's so cool. Wow, we did it. We saw the octopus is sinking. Oh, yes. So this is actually, what it reminded me now is this oscillation phenomena. Is like, yeah, yes. So it's like this where the metronomes sync. How is this phenomenon called? Damn it. Yeah, so it's this take the experiment weekly coupled together. How is it called? There's a name for this phenomenon. So you just put them randomly. Oh wow, that sounds horrible, sir. And after a while, eventually, they are in sync, and then they just keep going. Yeah, I want to know how it's called, this phenomenon, because come on, somebody in the comments, do it, be the nerd, be the geek. It's come on, somebody know what is called this phenomenon. I forget. Anyway, Anyway, so let's maybe not spend time to try to make this nice for now. It is quite 4.5 hours. That is 4.5 hours to write this much code. Um, well, at least it did solve the problem. So you know. So what I would like. Okay. Oh, okay. One small thing maybe. But how do I edit things? How do I Let's see. Matplotlib. Okay, I'm gonna do it. Come on. GCA. Let's remember how this works. Um, get the current axis. If there is currently no axis in this figure, a new one is created using figure add subplot. And it has these properties. Okay. What does it return? Oh, damn it. Snap. Okay, there's so there's snap. There's title. And I wanna. Damn it. Oh, I'm thinking now. How am I gonna do this? I need to capture basically. So I have the figure. So I need so I have the, let's go back here, pyplot. No, we're not in pyplot. Pyplot figure. Let's do it again. I need you to figure class. Okay, yeah, title layout. The figure is instance return will also be passed in new figure manager in the backends, which also allows to hook custom figure classes into the pyplot interface. Okay. Or maybe if you're creating many figures, make sure you explicitly call pyclose to the figures you're not using, because this will enable to take up too much memory. Okay. The default values can be modified. Maybe, let's see, maybe there is something in RC params that we could set. Axes. Maybe yes, please. Oh, some show or something. Line width, grid. Oh, damn it. Okay, that was too close. Tightly. Title Y. Okay, that was not as, it's meant as funny as I thought it was. Color bar. There is not even color bar here. Damn it. Okay, that was a dead end. What is this? Oh yeah, that was we don't want these anymore. Let's go back here. Set axis off. Damn it. Yeah. How do I access the figure object then? Because when the thing it returns is like this annoying thing that I cannot. It does not have a property that I can. That I can set and say, okay, no, I don't want you to have axes, for example, and I want you to have like this title every time. Is an artist? Usually artists are added to axis objects. No. Add axes. Add artist. Add axes. Can I just? Oh, there's no more here. Add subplot. Oh, why do we? Wait, no. Oh, wait. I just realized there's like an infinitely long page to scroll here. I totally missed that the first time. Okay, so where were we? Matplot pyplot figure with capital F is not defined in here. Okay. Oh, never mind. Set axis. No, there's get axis. Okay, axes. Okay. What does this do? List of axes in the figure. You can access and modify the axes. Okay. Uh, color bar. Add a color bar to the plot. Wait, is that returns color bar? Axes. Okay. Let's try. So maybe I can do this. I can do this. Perfect. So then the problem is get no. Okay, so it can read in. Okay, that's good. So then I have autocomplete. Axes. Get axes. Can I keep going? No. Okay. Set axes. Maybe false. Please work. And then I want to set in here. I want to set a title. Or maybe not. Maybe it's fine. Can I run this? Okay, that was unexpected. Mappable. What is mappable? The matplotlib blah 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 described by this color bar. This argument is mandatory for the figure method, but optional, which sets the default to the current image. Oh, can I get that? Note that one can create a scalar mappable on the fly to generate color bars not attached to previously drawn artist. So what's the described as color bar? Okay. So it takes this one, right? As color bar. What is that? A mixin class to map. Oh my god, what is happening here? Can I just look at the source code? If that's gonna make it any. Color bar, mappable none. If it's none, GCI. If mappable is none, BAM. Otherwise, get current figure. Maybe I can just do that. Maybe I can always do that. I didn't know that. So I can always do then matplotlib GCA wherever I am. Get the current axis. If there's currently no axis in this figure, which figure? Is it like maybe there's like a backend that knows which figure is on right now. Okay. And with this, we can set a title. Okay, so that's a start. Get current axis. Label. What is the label here? It says label will be displayed in the legend. No. Face color. How do I do this? God damn it. Maybe in this example, what was it? Maybe in this code here, maybe it was here at some point. Let's see, title. No, there's no title. Axis. Oh, there's just set like this. Damn it. Matplotlib. Remove axes from figure. What is that? Removing axis legends and white spaces. What did he try to do? Get axis set visible false. How you should do it. See. Wait. What will this work? Oh, but it's no color bar. Yeah. Can I do this? No, mappables was found to use for color bar creation. First define mappables as an image or with image show or. Okay, yeah. Okay, so maybe that is the problem. No, damn it, that was the problem. Okay, I need to. Okay, I want to do one more thing. So I want to set the plot title to step for now it's actually going to be just a 0, but let's make this 4 integers. And sorry, digits, yeah. And update it in here and in here. +1. Perfect. Okay, let's do it. I think it's gonna. I have high hopes now. Oh, please. Okay. Okay, the file has been flushed again, so now it's empty. Yes, it worked. So we do this. Oh no, come here. Oh wow, the resolution is great. Oh, but we get, oh, it's so nice. Okay, I have to improve the resolution. But it goes from 1 to 8. Ah, okay. Yeah, because there's no zeros. Ah, oh, okay, I see. Okay, but how big is this file? But we got it. Not too big actually, so maybe it's okay. We can maybe keep it. So I need to fix one last thing, and that is the color bar. Unfortunately, it should go from 0 to 9 to yeah 0 to 9. So let's go back to, let's close a lot of things here we don't need anymore. Let's go to color bar and figure out how to give it a range. Normalization values. If unset, the color map will be displayed on 0 to 1. So what? How do I set it? Is it what type is this? Values, boundaries. What is that? Tick location. Add lines. Add ticks. Minor ticks. Set tick labels. I want to set it to make boundaries none. Values. Oh, okay. So what is boundaries? Are they the same? But what is expected boundaries to be? Blah blah. Boundaries is let's see. Okay, where is it called? Boundaries. Make color. Oh, okay. Non or a sequence. Ah, okay. Ah, I didn't see. The following probably be useful only in the context of indexed colors. Boundaries, non or sequence, say values. Non or sequence which must be length 1. Well, okay, well, and less than a sequence of boundaries for each region delimited by adjacent entries. Is boundaries 0 and 9 in this case? Is like something I can do here? Boundaries 0 and 9. Will it crash? Oh, okay. Looks like it's working. Okay. Okay. So I don't think I need to set a git LFS for this one, but because it's not such a large file. So yeah, LFS is like large file storage for Git. Let's see. There we have it. Oof! Oh no, that is horrible. Okay, pyplot color bar integer increments. Discrete color bar. Yes, thank you. Blah blah blah. If you can create a custom discrete color bar quick and easy using boundary norm. Blah blah blah. Boundary norm. I saw this function. Yeah. So, how do they do it otherwise? Oh my god, why is this always so? But maybe the okay. Let's see, matplotlib again. Oh, boundary norm. Maybe it's optional. Maybe no. Damn it. Monotonically increasing sequence of at least 2 boundaries. Okay. Yeah, what will happen if I do it like this, actually? I for, or yeah, or I guess it doesn't matter, in range 10. So so if I do 10, it's going to be from 0 to 9. It looks like it's working. Okay. 4.5 hours. It's been real. Perfectionism is not good for you. It's not good for your sleep and not good for the people around you. So don't take my example. It's not even perfect, so. That's annoying. That is very annoying. Also, it started from 1. What? Did I get this wrong? Maybe it should be values. Oh no, I got this right. Oh, what? Number of colors in the color map to be used. Okay, so maybe that's actually easy to use. Okay, what does boundary norm do? Damn it. Can I use it here? Boundary. It didn't auto import, but anyway. From matplotlib color. Is it colors? Import. No. There it is. Boundary norm. What do you want? An array like monotonically increasing. So let's put our friend here. And then what do you want? Number of colors should be 10. Okay, I got a boundary blah blah. So let's put this here. Will this accept this one? I wonder. Oh, it's running. Okay. I'm not gonna say this is gonna be the last one. I think it's been an hour since I start making any promises of making this come to an end. I mean, we've solved it at least, so hey, bam, high five. Let's see, please. No. Oh no. No, that's not cool. That is not cool. Maps values to integers instead of interval. Oh. Okay, so maybe the problem is what it shows. So maybe the ticks are the problem. Okay, well, I'm getting too deep into this. Color bar, mappable. Was it color bar I'm using here, or I'm starting. My memory is starting to fall apart. Boundaries, color bar, yeah. There's not even. It's a keyword argument for color bar. boundaries. Tick location. So see map, mappables. The mappable whose color map and normally used. Orientation, spacing, uniform, proportional ticks. Locator array like or float. Oof, wow, this is getting deep. I just want it to be, what is scalar mappable? A mixin class to map scalar data to RGBA. Normalize the normalizing call object will scale data typically into interval 0 to 1 if none norm defaults to color normalize, which is scaling based on the first data processed. Okay, what was this? How did I do it here? Okay, bounds. What is bounds? It's linear space, and yeah. Okay, so maybe the problem. Okay, so maybe the problem is that it creates like an colors in between. Linear segmented color map. What is okay? I'm color map. Can I just get like a default color map? Am I making my life very hard here? Is there like some other amazing Python library that I did not try to use? Maybe Plotly would have solved all this in like just a few things, just a few let's see examples. Yeah, multicolored, customizable, vertical, from list of colors. Okay, maybe this one looks more reasonable. Virdis. Listed color map. What is this? Store the color values in dot colors attribute. Okay. There's a linear space. So this is like okay. So this no, but this makes like yeah the numbers in between. But I want them to be, or does jump? Oh no, it jumps by 1 to 12. Okay. Or does it? No, sorry. It creates okay. It creates 12 steps in between 0 and 1. Yeah, that's what it does. But that's not what I want to do. Okay, what is this? Creating color map is essentially the inverse operation of the above, where we set a list to make a new color. Before continuing with the tutorial, let us define the helper function. The one, oh my god. What does it do here now? So it goes for each, okay, whatever, like, it maps each color. What is this? To color mesh. This is getting too complex. Oh yeah, okay. Oh, this looks good. How do you do this? Oh, they make this. Did they use this? How is it called? Plot examples. New color map. So it's comparing the old one to the new one. So what is the old one? Listed color map. New colors. Pink. Okay. So it gives this. Listed color map. What is this? A color map object generated from list of colors. Colors list array, list of matplotlib color specifications or an equivalent and 3 and 4 color floating color point. Name is optional. Okay. Can I have an example where you just take like some basic colors? Multicolor lines. I just want a simple. Oh, that looks really cool. Listed color map. Why is it so complicated? Create continuous norm map. My eyes are gonna fall off. It's almost gonna be 5 hours soon. I've been sitting on my butt the entire time. Just fix this small thing, because it just pains me to see from 1 to. You know what? We don't need the color bar. fuck it. Yeah. Oh, that it even went much faster to without it. Okay, that's pretty cool. Okay, that took only 8 seconds. It took so much more with the color bar. Well, maybe I can add this in and see what that does. Maybe. Oh, sorry, I messed this one up. Interpolation none. Did it change anything? I wonder. Is it even visible? Probably not. Okay, anyway, we did this. It looks okay. Um, it's fine. I don't sound too convincing. But okay, we have some things here that need to be cleared. I will remove all this code. Throw it away. That was such a disaster. I'm gonna just remove these as well. That probably ate, like, yeah, you see how these things work. Like, you eat up so much time in things that really don't matter that much. So I'm just gonna write here, change, oh, wow, change this to the number of steps you need to reach. So actually, don't need to write it like this. We can make a markdown here that says run simulation. So this is going to be run octopus simulation, and we can say to configure the simulation, please input the number of steps you wish to reach, to simulate to. It can, the simulator, the octopus simulator can be used in 2 ways. Let's do like, oh, that works perfect. One way is set the number of steps you need to in the future that you need to predict to in order to get the correct number of octopus or the exact number of octopus flashes. And 2 is set the number of steps to a large number, like 500, in order to see if in order to find when the octopus's first sink. If you don't see any results, keep incrementing the simulation step number. Keep increasing, yeah, until you get a result. Perfect. So we can remove the steps out of here on purpose and put them in here. So then you can set whatever you like. So we can remove the debugging as well. We don't, it's not relevant to the solution anymore. And then just set a flash flag flag, just a way to true. So if this is set to true, then we can also let the user know that, okay, this happened. So by default, it's going to be false. So then we print this, and if simultaneous, if not, if it did not happen, print looks like the octopuses did not flash all together at the flash simultaneously in any future step of your simulation. Try increasing the step number of steps. Perfect. So that is nice. That is done. And save. We got all these nice flashes. So what I'm gonna do here now is, so gonna also credit this amazing person here. Oh, I closed the page. Oh shit. Okay, history. Let's find it. What was it called? Matplotlib or animation tutorial maybe. Yeah. Oh wow, that's actually I know it's wow. It's from almost 10 years ago. Blast from the animate. A blast from the past. A blast from the past. The great tutorial author Jake came to the rescue. With his tutorial, we managed to create a sweet animation of all of the simulated steps of the octopus simulation. And then I'm gonna tutorial, send it in there. Animate, perfect. Let's do this. We did it already. We don't need to do it again. Thus, we modified his solution to fit our submarine system. Okay, so I can also remove this one. Alrighty, we're almost there. So I'm just cleaning up a few things. Feel free to go to sleep or go about your day. I just want you to know you've been awesome, and it's going to be pretty fun to try to do this again. Maybe not necessarily Advent of Code all the time. Oh shit. Or not, I mean, not all the time, but yeah, I don't know. It's a test. Right now, it's been 6 people that at some point in time joined to watch me talk to myself for pretty much. So thank you for that, you six folks. You're pretty cool. Um, so I don't know. I don't know what I'm gonna do with this. So we'll see. I'm just gonna be trying this streaming thing once in a while when I have a lazy evening, instead of binge watching something. I just you know, enjoy a little bit of a fun time with you guys and ladies. So I'm actually not gonna copy all this. I usually just copy this in the for like future reference in the notebook, but I'm not gonna do that this time. Actually, I'm just gonna link to it instead. Um, Day 11. Too much text. You can see it for yourself here. TLDR. I'm just going to paste only the beginning of it. Unilarge cavern. Yeah, I'm just gonna put this piece of text in here. Perfect. I can actually wait. I think I only need to do this one. So now I'm just making them into like a nice quote. Yeah, it looks kind of nice. Okay, then we have this. This actually we can do up here, and we can. Yeah, let's also import. Okay, never used this one, so we can remove it. Import from ipython dot import display. So I want to do. The reason for this is because it's nice to print multiple things. But maybe I don't even need to. So I want to print the grid, and I want to print its shape as well. Yeah, that's fine. That worked. Then I don't need the display at all, actually. So let's print using your grid has a shape of blah blah, and it's been initialized as then maybe we can have a new line here. Perfect, yeah. Almost perfect. I hate this when this happens, but whatever. Okay, I'm gonna do it. It adds, I don't know why, I have never investigated it, but it adds a white space in the beginning, so now it looks nice. We don't want this anymore. Run octopus simulation, blah blah. The simulation runs, animate it, so I can just explain like real quick. Load real quick in here what we did. Clean your data, man. Remove new line characters from your data, and then also convert each integer, each digit, convert each row of data to list, or like a list of integers. And use hard to read list comprehension. No, wait. Yeah, how do I do this with this one, right? Let's see, comprehension. Well, how wrong did I get it? How should it be? What did I miss? Comprehend. I wrote it with a T, so nice. Okay, classic. Use hard to read list comprehension for bonus minus points. Why not? Perfect. Perfect. Then I'll just add a little piece here as well. Load and read. Yeah. Load and read stuff. Perfect. Okay. No, nothing. Okay, I'm gonna. So for this one, I'm gonna clean all the outputs actually, so we don't have anything in the output because it's images and they're always gonna be like annoying to update. Okay. But what I'm gonna do is I'm gonna write here. Be tada. Enjoy your sweet simulation over at Sweet Octopus simulation over at the actually this one here. So let's say it like this and put it like here. I think this one, I think that should work. Perfect. Yeah. Oh no, unable to open. Error, unable to open non-existent file. Ah, okay. Oh yeah, I know what's the problem. I think it's right. Yeah, it's solutions. Yeah. I didn't fix the correct place. So I need to actually take this away from here and just replace it here, basically. So this now should work. Yeah, perfect. Awesome. Amazing. So let's push it. It's over. We can go to sleep. It's freaking midnight. Oh my god. It's been 5 hours. Wow, it's been a blast though. It's been a blast. Even though the code has been like so little that has been written. But you know, it's all about having a good time. So let's do this. So we have the repository here. Oh, why did we modify this? Shit. Did I really add something? What is new in... Oh, okay, I updated things. Okay, Sphinx, hypothesis. Whoa, I didn't even know. I have coverage? What is all this? Wait, where am I? Poetry, shell, or lock. I don't use pre-commit. Why do I have pre-commit? Something else needed pre-commit maybe or something. Oh, but I will have to configure gitlfs actually because we don't want to have to care about this file. So okay, this stream is never gonna end because the video file we don't want to. I think I already have LFS installed. Yeah, we don't want the video file to be like updated all the time. Like have to change the difference if we decide to update it. Anyway, gitlfs. Oh, and do I have gitlfs? Actually, Okay, okay, I do. Git LFS, but I had a shortcut for it. That's why I didn't see any history. Or yeah, I remember. I've used Git LFS. I remember that. So how? What is it? Ah, okay, Git LFS. No, not that even. Okay, never mind. Anyway, Git LFS track star.mp4. Perfect. So now if I do git add dot git attributes, we can look at it as well. So it says basically, if you find a file that is named like it has this .mp4 ending, don't care about syncing the or like notifying the user about the differences. So now that I added this on the tracking, I can say git commit message and say I am do yeah, some emojis are fun. Let's add an emoji. Why not this one? Do not track MP4 files, man. And then we also want to do. Yeah, why did this bit poetry? Oh, a bunch of things changed now on this one. That's gonna become Sphinx. Okay, wow, like this is going. This is out of control. Now we have like too many dependencies in this thing. Anyway, git add this one as well because why not? Not sure about this one. And then we also have the data and the outputs. So let's add data day +1 git commit this alien emoji gimme show me the day. I've did this before. Nice. And then we want to add the solutions. And let's see, perfect. Git add, git commit, and make some like dance. We did it. It does not like exclamation marks, so we have to escape them. Perfect. Push it. Oh shit. Oh yeah, that's fine. The branch doesn't exist, so let's do it. Oh, what's the backslash in the beginning? Probably accidental. Let's do it. Oh wow. 6 minutes after midnight. Oh, that's going really slow. Okay, but there it is. Give me continue to GitHub. Yes, able to merge. It's done. Refactor it later, please. Day 11 is done. So if I make this pull request, I wonder. Actually, I want to update this one as well. So I want to apply this at every push. I want to. So I want to run tests on every push. Oh my god, this is never gonna end. GitHub actions on push. So I want the workflows to always run for all the. Do I need to specify branches main push? Do I always need to specify? Or can I just say on here on push? Maybe I can just say this, right? Or maybe not. Will that work? I wonder. It doesn't look good, for sure. Not sure if I can mix those two. But what I could do is I could just tell it to do all the branches. Anything. Oh, that doesn't work. Okay. Uh, I want to run all the branches. Can I do GitHub Actions on push all branches on okay, like do I have to do it with 1 star? Maybe that's good enough. Okay, no, this is yes, but okay, I can just put it like this. Dropping the restriction and push entirely means triggering on all of them. Okay, perfect. That is good to know. Then I should be able to do this. Git add, git commit, always. But then it doesn't matter. Then why do I need the... Wait, how does it look right now? Maybe I don't actually need to change anything. Oh no, it crashed. What? Oh no. What failed? Oh yeah, I tried to run the latest. So what's the problem here? It tried to run. I see the stack. Oh, okay. It needs. Okay, I see what's the problem. It doesn't have. Oh, maybe we don't need to run this one actually. Yeah. Okay. So it tried to run this as a test, but so it. So what was the error here? Everything with nose and zero. So what is the error? Got an unexpected argument, extra arguments. Yeah, so the problem is ffmpeg is not installed. So maybe we can fix that. But then this is going to be... Oh, no, this is not good. This is going to be trying to create the animation file every time. Okay. Oh, I need to use the restroom. Sharing too much. So maybe I don't need to fix this now. Maybe I can fix it later. I mean, everything is here, so... So if we go in solutions, outputs, how does it look like? Yes, nice, it plays. Oh, it's so sweet, look at it go. Wow, it kind of gives me this vibe that is like moving constantly towards my face. Like it's coming closer and closer, but it never really moves. Wow. It's so cool to see. Like this is pretty much a simulation of a like quite a complicated system, even though like the dynamics or like the rules of it are simple. The system itself is quite complicated. And look, now it's just like, bam, it's over. I could have stopped at step 400 actually. That's a few extra unnecessary steps. But I'm not gonna do that now. So it stops at 500. Okay, good. Oh no, shit. This sounded like somebody knocked on my door. Wait, what? Anyway. Oh, it's from the music. Wow, that was a bit worrisome. Okay, never mind. So okay, let's fix this real quick. Let's fix this real quick. I promise. So what is crashing the saving function? So if yeah, so instead of an error, because this is just an extra step, I'm only gonna say I'm thinking now, because if I ever test this in the future and it should still pass, but I don't want it to override. Okay, whatever. Let's install ffmpeg GitHub action. Let's do it like whatever. Doesn't matter. ffmpeg builds. Wow, that's gonna be set up ffmpeg. That's oh, it's an official action. Look at that. That's or is it? No, it's not an official action. I always get mixed up with these URLs. It's somebody else that made it, so that's a bit suspicious. Check out. It's not strictly necessary, but it may prevent rate limiting errors, especially. Maybe we don't want to do that. Can I test if ffmpeg is available, and if it's not, just because this is yeah, okay, I'm gonna do it like this. If the error is let's see, what was the type error? No. Python test if ffmpeg is installed. Can we do that maybe? Oh yeah, okay, there is a kind of a hacky way to do it. Actually, I'm gonna revert that to its original. No, that was new. That was right. Did I wait? How does it look this right now? Okay, I'm all over the place right now. That's not very good. Let's go to the 11 branch workflows test. How does it look like? Okay, it does this. But I did not add these lines now. Can I just check out this file? Yeah, just do it. Okay, I think, yeah, because I added it, that's a problem. Okay, never mind. Okay, reset. So that should be fine now. Perfect, okay. Okay, so we leave this as is, and we only test. There's a hacky way to do it. We could just try to run ffmpeg in a terminal and see if it's installed. If it's not, wow, that's a lot of output. Okay, you know what? Let's just do it like this. So the problem is that it can't. Yeah, okay, so try this except type error. But what? But it's strange, it's a type error. Should I? I'll just catch everything. If I never mind. As e print e and print error. The file did not get saved. And I think that's gonna be good enough. So if I let's see, what do we have new? Yeah, solutions. Git commit. Avoid errors. Let's push it. So now this workflow should run smooth. Let's see. Okay, we're in the queue. But I wonder. Okay, it's installing everything. I wonder if I can cache this as well, so it doesn't need to install everything every time. Also, what is it installing it from? Pip install. Okay, but I can switch to. I'm not gonna do it now. I'm not gonna do it now, but I can switch to poetry, so then it's cool. But okay, I think this is going to be good. Probably there's so yeah. Thank you very much for joining. I see there has been some people joining now. So hey, for you that joined now, it's been quite a bit. So I hope you're not gonna have to go through 5.5 hours of streamed content of me being like a crazy person. No, okay, we did not avoid the error. There something else happened, but we did solve the day 11 puzzle for what's it called? Advent of Code. So that took a little bit more than expected, but it was a little bit. I think I was a little bit too much on from my end. We got an error here that I'm not gonna solve now. That's not really a problem. It works if you go to the repository and you copy it for yourself. It's gonna be fine. The GitHub action is not working, but it's only there only to test if I refactor the main code, not the notebook, not the notebooks. So there is this submarine implementation here that I've been developing for no good reason to solve the advent of code puzzles in proper object-oriented programming in Python. Nobody asked for it, but hey, it's fun. So I hope you had a blast. I hope you. Hey, Annie, that's funny. Hello. Uh, Nice to see you. I hope Copenhagen is treating you well. Um, I'm gonna have to end it now. So maybe next time I should actually notify people that I'm doing this, so maybe people can join. So super awesome to see you here. You don't have to watch 5.5 hours of a stream, except if you really don't have anything to do. Probably gonna do this regularly or irregularly. We'll see. Whenever I have some chill evening times that I don't have much to do. So I hope you all have a great evening. Have a good one. See you around.